All right, ladies and gentlemen, welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert level science. My name's Ken Hansen. I'm associate professor in the Department of Chemistry and Biochemistry at Florida State University. I do all things light matter interaction, photons driving chemical processes. But more importantly, joining me today is statistician Dr. Jonathan Stewart. Jonathan, if you wouldn't mind introducing yourself.
Sure. So like Ken said, my name is Jonathan Stewart. I am an assistant professor in the Department of Statistics here at Florida State University. My research focuses on a field called statistical network analysis, where we're interested in learning about the networks of our world, which could be social, biological, brain networks. They arise in almost every facet of our studies, and from the social sciences to hard sciences and more. So I'm going to be excited to share some of that with you all tonight.
All right. Equally important, what game are we starting with?
I think we're going to be starting with Star Fox 64, one from my childhood.
Yeah, this one's near and dear to your heart.
Yeah.
All right, go ahead and get started. We'll relax a little bit while you settle in. Also, I think we get to watch all the animatronics.
Okay, yeah, there's a bit of a startup here. I guess I could skip this, but...
Oh, we need the lore. We need the backstory.
I guess we have 3 hours, right? So
take our sweet time.
we can read.
So Star Fox, though, man, that came out in 1997. So you were what, middle school then?
Yep, I think so. Yep.
And that's when it took over your life for a brief interval of time.
Well, 1997. No, I wouldn't have been in middle school yet. Actually, no, I would have been 7. So I would have still been in New Orleans at that time. So in 2000, I moved to Houston, which was middle school. So, but I played it in middle school still, I think.
Yeah. No, this game had staying power. It was popular, like one of the early on a rail games.
Yes.
Let's
So, should we get started?
Yep, let's do it.
Okay.
So I was familiar with Star Fox when it came out for the Super Nintendo, and it was like a big deal, right? It wasn't, the graphics weren't as good as this. It was very like pixelated in shapes, and it was like, platonic solids composing ships and things like that.
Yeah. I imagine, did I break it?
Nope, it's
there
going.
it goes. Okay. So I imagine, people watching at home look at these graphics and wonder, but this was at one point, you're right, it was the height of graphics in video games.
Yeah. Reese's Pieces, you're right. The vector graphics, it was cutting edge, right? You needed that 16-bit to do something. It was magnificent gameplay. Turn it up so you can hear it a little bit.
Look at those hexagons, yeah.
Perfect hexagons.
Just wait till you see the lasers. Get a look at them.
I like the voices on it.
So I guess there's no way to skip those.
No.
So,
Maybe there is. I don't know this game well enough, unfortunately.
I don't know that. Forgot.
So we do have Infinite Lives cheat code, everyone. So I apologize if you're offended by cheat codes, but they are active in the game right now.
I'm not quite good enough, I think, to do it without. Yeah. All right, where are they? I gotta help Slippy.
All right, ladies and gentlemen, if you have questions on statistics for Jonathan Stewart, particularly you're big into network theory, you're more on the theory end of things than applied.
That's right?
So describe it.
I one of the problems with kind of statistical learning is understanding when the problem you're trying to solve is solvable, because there are limits to what we can learn from data, right? Think of how many points you need to fit a line or a quadratic or a cubic, and so when we start to think about data, we have something called degrees of freedom, and if you don't have enough data, you can't learn particular systems like linear regressions or other things, other types of models. But it's really hard to play the game and answer.
That's part of the fun. Yeah. Have more beer, it'll help.
Yeah. But in terms of the theory, the reason why the theory is so important is to make sure that when we ask questions, scientific or statistical questions, that it's mathematically solvable, that we're not, searching for an answer that doesn't exist, so to speak. And so my research largely focuses at giving us a better understanding of basically those types of situations. So I think I have some questions here.
Yeah, I will throw those at you quick. Reese's Pieces, what is one concept from statistics that other scientists get wrong the most, and why is it p-values?
Why is it p-values? I don't know that it is p-values necessarily. I mean, p-values get a bad rap, but the problem with p-values is really a problem, I think, with replication. When we think of an experiment, so let's think about what a p-value is. If I'm running an experiment and I'm going to accept, say, a 5% error, type 1 error rate, so I'm looking at 95% confidence intervals, what I'm really saying is that if I were to run this experiment again and again and again, I would expect to make the wrong conclusion only 5% of the time, right? That's a type 1 error. And so I think one of the problems with science is that we're not rerunning experiments enough. And so you see a study that finds a very low p-value, but you never know to what degree, it's stochasticity that's detected this, effect, or whether it's, actually something that manifests in our world. And I think that scientists need to do a better job of self-criticizing their own work and understanding when something hasn't been investigated enough. So I know meta-analysis tries to combine studies to address this.
So it's not p-values.
I don't know. I mean, p-values are misunderstood, but I think they're misunderstood for the wrong reasons. They're misunderstood because of problems that arise. People are really good at dealing with situations when they expect the outcome, and that's, statistics and probability are all about understanding uncertainty. We don't know what's going to happen in a given experiment, but we want to understand the randomness that governs it. Wow, it's really hard to do a boss fight, and
it's going to be hard to do all this.
Yeah, I know, especially with my dinky laser.
To make it work, Cheap Scientist has just redeemed Take a Drink. So, okay. Jonathan, cheers.
Cheers.
Don't worry, Infinite Lives. It's a pleasure having you on.
Yeah, pleasure to be here, Ken. Thanks.
Still early in the night, but excited to play some Star Fox and talk statistics. So earlier we talked about, and this was off stream, is we talked about, survivor bias and sample problems. I mean, that's a major problem with the statistics, like the raw data you get out. Yeah. And so that's an underlying problem that's pretty systematic, right?
Well, quality of data is a problem, right? People say, oh, you like networks, you must love Facebook. No, I actually do not. It's, in my opinion, some of the lowest quality data you could possibly get.
But there's so much of it.
There's so much of it. But, I love something Kathy Enser said at a conference recent. She's going to be, I think she's the president-elect of the American Statistical Association. We see people focusing on big data, right? That's really hot. Everyone wants to do big data. But she said, and I think it's really important, is not all data is big. And if you have a really well-specified problem, you presumably are collecting the right data. Big data arises out of a need to, analyze tremendous troves of data, which is important, but not all data is big.
Mm-hmm.
And so, yeah.
The shorter answer is delete Facebook. Delete it right now. They're acquiring data they shouldn't be. Like, they're listening to you as we speak.
Well, I'm very nervous about this because, when you have so much, just an extraordinary amount of data, I don't know how. Why is this guy not dead yet?
It's phase 3.
Yeah. When you have an enormous amount of data on people, you can really learn a tremendous amount. There's an entire field called Differential Privacy devoted to understanding, essentially when you can uncover someone's identity. A really kind of crazy example of this, and more. It's much broader than that, but just in a sense, even if you essentially delete your anonymized data, that's not enough.
It's not true.
And a really important example of this was the so-called Netflix data set, where they thought they basically controlled for people's identity to protect them, but actual people found themselves in their rankings of movies. So they took all the rankings and they removed some and basically just gave you a subset. But some people actually found themselves. Now, it's been a while since I've read about this, so I don't remember exactly the But people found themselves in the data, and that's really bad. And so I get very concerned when we start to talk about the tremendous amount of data that we're allowing people to obtain about us.
There's a really fun short story. I don't remember this might have been a Black Mirror episode at some point, but it's about the predictive capacity of this information, right? Because we put in a Google search and it predicts what we're going to do and what we're going to say, and you can individualize that. But that data set could essentially replace us online at some point. And it's basically somebody could die in their apartment, and if that bot takes over, it might be that person. You couldn't tell.
Yeah,
because it recreates that individual.
Well, I mean, it's really interesting because one of the things that people have done with Twitter is they've tried to create bot detectors, right? Especially if you're trying to motivate people on some kind of social media platform. If I know a bot's just spewing something, I'm less likely to give it any merit. But if it's someone making a cogent argument, maybe I think about it and say, I wonder if there's something to that.
Do you have to shoot this guy's legs out? Is that the?
I don't know. I forgot. You just I think in this game you just shoot him, and if it blinks, you keep shooting.
It's simple rules.
But look, his chicken's down, so he's done now. But I think he's shooting missiles or something.
You've done it. I don't know. Scuzzbot wants to know: is this essentially a remake of the SNES Star Fox? Not an exact remake, but same principles apply. So this is more flexible than the original Star Fox. So the original Star Fox was a very on a rail shooter. I don't know if you're familiar with that terminology.
I have seen it,
but it's like you're going to go straight. You can go left or right a little bit, but you're restricted in space. This one you can do loop-de-loops, U-turns, and all sorts of stuff.
Oops.
So a little more flexible in that case.
Yeah.
All right.
Well, we passed one planet now.
No, that's victory.
With what
was that, one death?
Quite a bit of effort, yes. But my ship's in tatters.
Yes, we will celebrate.
Totally destroyed. I need a new one.
All right, Scuzzbot wants to know: have you worked on any problems related to COVID?
Explicitly, no. And I'll tell you why. Of course, I mean, there's an entire field called network epidemiology. And of course, diseases spread through networks. You come into contact with someone, there's a possible infection event. And for diseases like HIV and other diseases which don't spread as, I would say, as quickly as COVID, it's possible to construct these networks and study them. COVID is so communicable as a disease that it's almost impossible. By the time you would even construct or you would perform the contact tracing, you've got at least twice as many new cases for which you have to do the contact tracing. So you can't possibly keep up. And the health departments across the world have been totally overwhelmed. And so from a network perspective, it's really hard to do something, I think, real, because I don't know that anyone really has good data. And the other thing is why I haven't is because everybody's working on it. Sometimes if something's too hot, there's a lot of funding for it, there's a lot of interest, but there's also a lot of competition. And it's not something that's really in my purview of what I'm really interested in. So I'd rather stick to what I'm really interested in and let other people work on those types of problems. Because I don't know that my specific tools are the right tools for the data that they have.
That's kind of fun. We loop back to quality of data question, right? So Matt Hauer was on. He's a sociologist who studies he studies aging and human health and well-being, and he described COVID as a fire hose of data, or a fire hose of science that's just bombarding us constantly. I mean, it's going to be interesting long-term, see what because people can reverse engineer these things. Even through Facebook posts, they can contact trace to some degree. But that's a lot of noise.
I had wondered about the feasibility of using cell phones. Now, there are a lot of privacy concerns with what I'm going to suggest, but I mean, if there's a serious...
No, let's answer this question. If you had unlimited resources and no moral qualms, what would you do? Go.
If my goal was to, reduce the impact of a disease like COVID, I would use I did it right. I remembered how to do it. Good.
Nice.
Some of it's muscle memory from 20 years ago.
Yeah, hours and hours of gameplay.
But if this got really, really bad, one thing we could do is, instead of quarantining entire country, I thought, well, why don't we use geographical information? I mean, in a state of emergency, is it so outrageous that we would use people's cell phone data to say, you are possibly at risk, consider quarantining, or quarantining, particular cities or other things.
I mean, that's real data contact tracing, right? Like a radius.
But there's a lot of issues with that, and it's not clear how one would implement it. Something really interesting that was done in Houston was wastewater analysis, looking at viral loads in the wastewater. And they have actually block level data in this. And so they were able to actually send, I think the phrasing that was used was SWAT teams, as it were. I forgot what it was, but teams to go in and do interventions. To, say like, hey, go get tested,
Yeah, when the dust settles on this, it is going to be breathtaking to see what actually unfolded. So one of my favorite examples...
If we ever know.
I mean, we'll learn a lot, right? And we'll be doomed to repeat it anyway, but we'll still learn a lot, presumably. But one of my favorite examples of this, are you familiar with World of Warcraft, the corrupted blood disease? You heard of this?
I'm not so sure about that. Can you remind me?
So it was basically, World of Warcraft has many different levels of characters, and so you could be a level 40 character in a level 5 dungeon.
I see.
And there was a disease that was meant to kill low-level players. But when a high-level player got it, because they were escorting a low-level player through the dungeon, they basically survived it. And they teleported out of the dungeon, and they brought it to a city. And they essentially transmitted this disease throughout the city, and it wiped out something like 80% of all players on World of Warcraft.
Wow.
And so, epidemiologists were using this data set because it's perfect, right? It traces every moment of transmission. And so they were using this to model real plague transmission. And so just a really fun...
That's really interesting. Yeah. I wouldn't mind having that data myself.
No, I'm sure you can find it. I think it's readily available. And it's, if you can apply some of your methodology to it, I mean, who knows what... Yeah. What a perfect data set.
Right.
Well, it's actually... Sure, people fly and everything, but we'll ignore that.
Well, it's not actually the first time that video games have been used to cultivate data sets, because you're in a situation where you can essentially monitor everything, because everything lives within a game. It's all recorded. It's just about whether you save the information, right?
Yeah.
And I wonder, as we get phones, as we get more cameras, and our ability to surveil becomes better, if we're not kind of looking into the future,
Yeah. I mean, the data exists. It's like a matter of compiling it in a useful way and something that can be interpreted. That's really fun, but also terrifying.
Well, it's terrifying because the legal world moves very slowly. And one of the really important things, I think, with information, and is understanding that just because someone was in a location at a given time doesn't mean they committed a crime. And actually there are examples, I don't have them off the top of my head, but there are examples of people who have been convicted of crimes because they were the only person found there, or they had information that they were in the region, and it's come out years later that, oh no, actually they were innocent. And so I mean it's just similar types of things that have happened with DNA analyses, where you say, oh no, how could it not be you? But it turns out it wasn't.
Yeah. There are error bars, and there's reasonable doubt. I mean, that's what's terrifying. Like, the more, and this is an issue with the CSI shows, they have given juries this artificial sense of what is actually evidence, right? Like, it's the DNA, it's done. Your cell phone was there, it's done, and it's kind of cast doubt on a legal system that relies on reasonable doubt and what that means.
You're kind of just describing a larger problem of this gets to people thinking that they're epidemiologists when they decide they do or do not want a vaccine, I think. But understanding the difference between an expert and someone who has a little bit of knowledge. You can actually have a lot of knowledge about something and not be an expert in it.
That's the Dunning-Kruger, right? The artificial sense of knowledge. Mission 2 completed.
Mission 2.
Congratulations.
All around, to all of us, really.
Don't you feel the victory, the joy you had as a child?
Yeah, it's great.
I love it. And confirmation bias. Yeah.
Confirmation bias is a big problem. Which is very related. It's just survivor bias is just a variant of confirmation bias. It goes back to, if we expect something to happen and it happens, everything is according to plan, as it were. But when something unexpected happens, we freak out. So we're very good at noticing when something doesn't happen, but we fail to take account of all the times that something that we expected happened. And this is related to gambling and other things where people don't people notice all the winners. Oh, they won, that person won, I could win too. Not likely. But
speaking of which, do you play the lottery at all?
No, never.
Do you gamble?
No,
poker,
never.
Blackjack?
Never, nothing.
I mean, poker is a skill game to some degree, but you stay away from it entirely.
I don't know that I have the skills that I would need to give myself a chance.
That's fair. But you definitely don't play craps or like roulette or anything that the actual numbers.
No. Because knowing the odds of how you're going to lose doesn't help you win. It just says, it just helps you know how you're going to lose. There are very, very few games in which you actually, could make money, especially at a casino. Everything's very, very controlled, there, because they're very interested right there. They're a whole business of, making money and not losing it. So what they're selling is a fantasy.
No, it's true. I mean, they're selling the endorphin rush, right?
Actually, that was interesting. There's an economist who framed it that way, and I thought that was a very interesting take on the matter.
Yeah. I mean, it's a drug dealer, and the drug you have to pay for releases on, the small victories and confirmation bias.
Yeah. Well, it's manifest in gaming too now. I don't really play a lot of games, tonight being an exception, but I was reading an article about gambling in games and all these I think they're called loot crates or
loot boxes.
Okay.
Yeah.
And that's well, I'm glad that wasn't around when I was a kid.
Oh yeah, no doubt. I mean, especially the ones you have to pay for, like pay to win, and kids are just obsessed with it.
Yeah.
I mean, in Europe, there's all sorts of laws going in because for those of you not familiar, loot boxes are essentially, you open the box and hope you get whatever prize it is, and sometimes you have to pay for that box. And this is a manifestation of gambling in the gaming world. And so they were having kids essentially gambling. It's illegal, and yeah. Uncle Bill, welcome. Reese's Pieces. I read an interesting take about the difference between novice and expert in a topic. If you compare a chess novice with a grandmaster, the grandmaster is orders of magnitude more competent, to the point that the novice doesn't recognize their level of disadvantage. Uncle Bill, thank you for the host.
I'll need to read that one. Unfortunately, a pig, a wolf, and two weirdos are kicking my butt right now.
No worries, take your time.
Let's see, I read an interesting...
But it's basically saying that the grandmaster is orders of magnitude better than the novice. The novice doesn't even recognize their level of disadvantage. They don't even know how far over their head they are.
Well, that's kind of a statistical problem in a sense, right? I mean, if you flip a coin, if I give you a biased coin, right? The ultimate bias would be a double-sided coin, one with two heads, right? But and you flip it a whole bunch of times, and you only get, heads, and you were trying to get tails. You know that you're not favored to win, but can you estimate your odds? And the answer is no, because you have no information about what it's like to lose. You've only, how would you estimate this probability? You would take the total number of times you won the game and divide it by the total number of times you played it. But what does 1 or, 0 mean? I mean, how do you interpret, very, very unlikely if you don't actually, see the nature of how unlikely? Just, you never won, So is it, 0.0001 or 0.000001? You don't know. And you'll never know unless you play it a whole bunch more. But so I think you're kind of in that setting where you get no information about the difference between the two of you because you're just totally overwhelmed. That would be that's how I would think about it statistically, is you don't have enough information actually to estimate the difference.
Yeah. No, and I feel that sometimes. Like, I watch Twitch and I watch other people game, and there's some games that I know like religiously, like Super Mario Brothers. I know the ins and outs of that, and I'm 5 seconds away from the world record, but that 5 seconds is a lifetime of gameplay. And I'm good enough to recognize where I'm off by 5 pixels. But if you're an amateur gamer, I look pretty similar to them. And so it's, shades of Dunning-Kruger, as Bill put it. Yeah. That's interesting. So you frame it as a statistics problem. So
I think in terms of statistics a lot of times.
Well,
it's how I rationalize the world.
Yeah. It's your skill set. So unlike I can describe how these things generate light, but you have a generally applicable skill set to everything. And so
some things.
Is that a blessing and a curse, or when you watch election night, is that a waking nightmare?
For different reasons. So Amanda at the New York Times. Oh gosh, what's her last name? I can't remember her last name, but she got really famous when she got really famous for revolutionizing the way that they did data journalism. Basically, they made a lot of these great interactive graphics, and one of the things I asked her about is, how do you communicate uncertainty? And so she brought up election night, so the needle. So I don't know if you all seen this, but it kind of bounces around to give you a sense of who is more or less likely to win a race. Communicating uncertainty is really, really, really hard. And so that I think that's a big challenge.
Yeah. Oh, that makes sense. What are your thoughts about Nate Silver from 538? Either baseball or politics predictions.
I don't really pay attention to that. So I don't really pay attention to him. I don't know.
That's fair.
Oh, look, I've lost 2 people.
It's okay. Infinite lives.
Yeah.
We could probably get them infinite lives. But we're not gonna do
I don't know how to do it.
So are you familiar with Moneyball? Have you seen
the Astros? Well, because I'm from Houston. So.
Oh, I see. So that's.
So I think that's just getting at the general value of data analytics in sports. And actually, I had some rocket data in a course in undergraduate, and we made a plot of the entire court, and for each player we could visualize the likelihood of where they would take their shots. You could make it proportional to, oh, what did I hit?
Oh, interesting.
Uh-oh.
We're okay.
Okay. So what did I touch now? I broke something.
No, we're okay.
And so you could actually visualize, the likelihood they would make the shot, how many points they would get from various points in the court. In baseball, there's a lot of this too, where you throw the ball, how you throw it, what speeds. There's a lot of data. I haven't really looked at any baseball data, but there's so much there. And if you can use this data in a meaningful way, you can understand which players you should get. You should understand which strategies actually are decent strategies. In football, I think 2-point conversions is a big sticking point. And there's been some interesting data with that where people tend to not go for it. But data suggests they should go for it more than they do. How much more? It's another question, actually.
I mean, there are volumes, like encyclopedic volumes, written on like at this certain time in the game when you're down by this. And, like, I don't know how rigorous their analysis is, but I mean, it's definitely drawing on.
My understanding is the analyses that are put into play, because I was at a conference where they did talk about sports analytics as one of the sessions, and recently, and my understanding is certain aspects get heavily data mined, and certain aspects don't. Like, some things are really basic, and then other things, like you found out in Moneyball and other things, is they're really trying to maximize the information and data that they get. If that makes sense. I'm trying not to get hit by robot arms.
So, I mean, the people that are doing like the sports betting in Vegas, I mean, these are statisticians, right? These are...
Oh, for sure. There's significant... where there's money, there is good analytics, generally speaking. I don't know how much I would bet on that statement, but more often than not.
I mean, they have millions of dollars at stake. The Knowledge Fellowship. Thank you for the host. So those of you not familiar, the Knowledge Fellowship is basically a group of educational streamers such as ourselves. Some play video games, others don't. These are artists, these are educators, these are people that teach classes online. So check it out, Knowledge Fellowship. There's a link right there. It's on Discord. You can join it and meet all sorts of educators from math, physics to statistics to whatever it might be. So Knowledge Fellowship, thank you for the follow, and click on that link. All right, speaking of which, Uncle Bill says, statistics does make an interesting analogy. You need a certain size of data set to even see there are gaps in the data set. So circles back to the garbage data, right?
Well, another issue is how representative your data are. So at certain times in our history, there's been populations that have been totally underrepresented in the data, and so certain effects were totally unaccounted for. And these are called so-called hard to reach populations. They're hard to survey, they're hard to collect data in the social sciences. So, I work primarily in social network analysis, so I usually think about statistics in terms of social terms or economic terms, but this was a big issue, and actually respondent driven sampling, which finds roots in statistical network analysis and network analysis in general, is one way to get to these populations. But just to plug that, but
that makes sense. Back to the football. If you make a 2-point conversion more than half the time, you should go for it.
Yeah.
If you score an infinite number of touchdowns, that would be a true statement. Right?
So it turns out, and I saw a graphic of this recently at the conference that I mentioned, is it depends on where you are on the field. It depends on a number of factors, but there are times at which you definitely should, and there seemed to be a kind of bias to not want to go for those types of things. Like, it was thought to be a very risky strategy.
Oh, so it's superstition driven.
That was what was asserted by an expert in
not
sports
in
analytics. I'm not I don't study sport analytics, so I can't really say one way or the other. But
I mean, that's what's weird. So, like sports, there are certain unwritten rules that people follow for no apparent real reason, right? Like there's in baseball, there's like weird if it's 2 strikes and you're down and you don't swing and blah blah blah. There's all sorts of stuff like that just it would come through in the data, but not for right.
Well,
right.
That's why data is so important. Is in probability. There's so many results are actually very counterintuitive. And statistics is really about making sure what you expect and telling you when you're wrong if you expect something different in kind of very broad terms, informal terms, perhaps.
Scuzzbot follows up on the try a 2-point every other time. It's wouldn't an increase in 2-point conversion attempts influence defense and general game strategies, ultimately impacting the likelihood of success? I mean, it's combat statistics, right? There's a feedback loop. They recognize what you're doing.
So, that's an interesting point, and when you think about the data of people should go for conversions more often. That might be, games. You can think of game theory, where you have strategy and randomness because you don't know what the other player is going to do, and you can think of it this way: if the data is collected under certain circumstances and you change the circumstances that, now everybody starts to go for these 2-point conversions, it actually might be better to not go for it because people might get really good at defending against it. Yeah. So what you're describing is a kind of change in the system, and that's something that statistics can only learn if you have data. So sometimes we'll make suggestions based on data, and those suggestions are implemented, and the opposite happens. The opposite thing that you want happens, and so people say, well, what happened? And you say, well, the system changed. You changed something in the system, and now it's behaving in a different way. It's you can think of it like correcting.
Yeah.
And this is just you can think of like if they change the rule to a game and the new strategy now is different, the Nash equilibrium, so to speak, it changes. It might be that your decision from the previous rules of the game didn't apply, and statistics is really just about rules, right? Yeah. You collect data, you learn the nature of randomness in a system, and then you hope that the system doesn't change before you try and make a prediction.
I mean, so you have a very Heisenberg uncertainty issue. The act of measuring and/or implementing something changes the outcome, right?
Well, it can if you're thinking about interventions. So if there's a disease spreading through a community and you want to educate people to not spread the disease, that you're talking about an intervention. You're trying to change how the disease spreads in the system. So, some of the things that we've done or not done in with COVID is, why did we all start to socially distance and wear masks? Because we didn't want to get sick. We changed the way in which we interact. So if I built a social interaction model pre-COVID, it's not going to be very useful during COVID because the whole system's changed. The rules of the game are different.
Unless you're in Alabama, then it stayed the same.
Did it?
No, I mean, we do have contrasting data sets, right? Where masks policies were mandated and implemented, and California is doing vaccines for school-age children. So I think we're going to have some really interesting comparative data sets.
Yeah.
Reese's Pieces. One of the lessons I learned in my statistics classes was about not throwing out the outliers. The story goes that some climate scientists were sampling data and kept getting outliers in the data that didn't make sense, so they ignored them. Those outliers were sampled in the 70s and predicted the shrinking ozone that eventually ended up happening. It makes sense.
So how you interpret rare events, or, that's what an outlier is, right? A rare event.
They call it the black swan events, right? Yeah.
So there's kind of two issues that I see in this, and The first issue is, it's a viable data. So not all data sets are equal, right? Some data sets are more representative of the system or the experiment in question than others. A nice example is I played a game in my statistics class. Basically, it was like a multi-round rock, paper, scissors is the fastest way I can describe it. And after 5 rounds, the number of people who were not eliminated was, I forgot what it was. It was like 6 or 7. And we did the math in the class and we showed the distribution. And it turned out that, the probability we would get this outcome was like 3%. The probability that the number of players that we had left, like say 6, the probability that 6 or more players was left was like 3% or something small. In other words, it was a rare event, but it happened in real time. We all saw it happen. And that's what really outliers are if they're part of the data. Now, sometimes outliers arise because they're wrong data points, and that's when you should throw them out. But
Figuring out if they're wrong or there's something unaccounted for variable. I mean, that was the issue with global warming, because the climate change, as it became to known, ozone hole screwed up that data, but also led to a Nobel Prize. So somebody. And that's fun. In your classes, you do like coin flips and rock, paper, scissors, and here we are in chemistry talking acid-base chemistry. I'm just a bit jealous.
Well, I mean, for my, I one of the fun things about probability is I think there's just something nice about experiencing it.
Yeah. I mean, demonstrating counterintuitive outcomes and like
just actually, getting to put your hands on, a real-world experiment and then rigorously analyze it in real time to understand, what it is you were doing. I don't know why this guy's not dead yet.
Yeah.
What's he
doing? I just want to acknowledge how awesome this bad guy is. Like, he was talking shit at the start, like challenging you, and then swinging arms around. I think that's the best use anthropomorphic robot fighting in space, but whatever. I'm not the bad guy in this game.
But I mean, one of the things, just about statistical learning in general is, I love the phrase garbage in, garbage out. And one of the really interesting things about the ozone data is we can't go back in time, right? I mean, even if there were infinite universes in which we could observe infinitely, or sample, all the possible ways our universe could have evolved, we only get one data point. We only get our data point. And there are some problems you cannot learn, but, under certain assumptions, we can start to learn them. So we can learn trends over time if we make some assumptions about how these trends evolve. So temperature trends. So this would be like a time series. But when
this guy slapped Slippy to another world, is that what this level is? Find Slippy?
Yeah. So there's a number of routes you can go.
Oh, I see. There's actual
and in this one, I forget how it works, but in this one, Slippy gets sent away, and now I guess we've got to go rescue Slippy.
You got the bunny back. What's his name?
Yeah, I think they sit out once.
I see.
I don't know.
What is this? You're a tank?
I'm a tank. Yeah.
If
there's a path you can go on the left where you can be a submarine. Oh, those are mines.
I did not know any of this.
Yeah.
I'm learning a lot, both statistics and Star Fox related. So you talked about like theory and not necessarily applied. So do you use data sets, or are you essentially doing proofs to demonstrate concepts? Like how does that work?
I think statistical learning requires 3 things. I call it a triad because I like triads in research. It's appealing. Science is the first, I think. The problems, it's nice to know things about mathematics and statistics and probability, but I think science is really what drives us. Why are we interested in the models we're interested in? Why do we study the problems we study? Because they're purportedly useful to the world. And we want to learn something about the world that we didn't know. There's a way to hover. I forgot how to do it. Oh, there we go.
Bumper.
Yeah, there we go.
Nice. Oh, look at that.
Oh. And oh my gosh, hold on. Sorry.
No worries. It's
It's
intense.
too hard to do more than one thing.
I know, you're doing great.
Yeah. Sorry, what was the question? I've totally forgotten it now.
Well, we're talking about so like real data versus, doing proofs with
yes.
axioms assumed, and like, yeah, you talked about science and
So when the proofs that I'm talking about are going to be like, we've got some kind of model we want to estimate. Maybe it's a model for a social network. Maybe it's, it could be whatever model. But we want to estimate the model from data because we want to pick the model in a sense that best represents what we are observing. And so it turns out that it's very non-trivial to show for these modern, statistics problems that certain estimators are even consistent. That is, if I keep observing more and more data in a well-defined sense, that my estimator will get closer and closer to some theoretical truth. And it takes a great deal of effort to show this for certain types of models and certain types of estimators, and a lot of modern statistics has focused on these problems as well as others. But one of the reasons that this is important is you might remember from your statistics course the central limit theory, right? It's the most famous statistics theoretical result ever, perhaps. It revolutionized the way we did science. It is why you have p-values, basically, and so what the central limit theorem says is that if you take an average and you appropriately normalize it, then it'll become more and more normal in its behavior, Gaussian in its behavior. And this is kind of the foundation for classical statistical inference. But there are assumptions to that proof. Not to get technical, but the variance of your distribution needs to exist, and other technical results for depending on which version of the theorem you're requiring. And so there are distributions that are used in the world for which these conditions are not satisfied. Okay, I'm just taking so much damage.
no worries.
There we go. And so one of the things that the other kind of part of the triad is, so I said science is at the top. On the right leg of the triad to me is theory, understanding that the problem you're going to try and solve, or the model you're going to use, is well posed in the sense that you can solve the problem you're trying to solve. What you're doing is sensible in a sense. The other leg on the left, to me is kind of your methodology. How do you go about your sample design? How do you go about implementing this? How do you go about computing these things? A model, it may technically be problem may be solvable theoretically, but finding the solution can be very hard sometimes, computationally speaking or otherwise.
So when you're doing this from a theoretical perspective, and correct me if I'm wrong, you have to know what the answer is to know how close you are to it. Like, you create a theoretical optimum and see where the assumptions take you? Like, how does that?
Well, kind of. So usually we start by creating a problem state, and then we want to prove whether the statement's true.
I see.
It might be, if I observe data from this model and I estimate a model based on the observed data, then the error of my estimate can be bounded above by some amount. And that would be something that I work on, estimation theory, where I'm looking for upper bounds on statistical error of estimators. And what we can learn from this is we can learn the scenarios in which we will expect to have good estimators close to the truth or estimators far from the truth. And so what we're trying to show is kind of the classical side of statistics, where if I observe more data, I expect to do a better job at estimating, the nature of the randomness that I'm observing. In other words, my standard error should be lower in a kind of a classical setting. So if you think about a confidence interval from your statistics courses, the bounds on that are a function of standard error and the amount of data you have. So the standard deviation, the amount of data you have. So the standard error decreases as you have more and more data. So you have more confidence when you have more. So if you have a fixed level of confidence, that confidence interval will shrink. And so you're saying, okay, well, I'm 95% confident that the mean is between these two numbers, but as I observe more and more data, that those two numbers will get closer and closer. So I'm able to more confidently assert where the mean is, in a sense. I can abuse the terminology a lot.
You can do anything you want on Ask a Scientist Gaming.
I'm trying very hard to keep it informal and not become overly pedantic.
Yeah,
I don't know if I'm doing a good job of that, but
I mean, I'm following for the most part, so I'll consider it a victory. But we may have some actual statisticians in the audience. But speaking of which, anyone just joining us, again, Ask a Scientist Gaming, mediocre gameplay, expert level science. In this case, we have statistician Jonathan Stewart joining us today, who's happy to answer any questions you have on statistics, big data. He's happy to talk about it, network theory, anything you want to say, throw it in chat right now, throw your questions in there, and we are happy to discuss them. So this boss is another just gem of this game. Look at that guy.
Yeah, so I mean, in this game especially, you'll find that, you get a lot of these kind of weird monsters with many arms where you just shoot off the arm. And
it's a metaphor for life, really.
Yeah.
Alex Robb has redeemed take a drink, but we'll wait until you're done with the boss fight. No pressure.
Well, I just don't want to have to go at this again.
Yeah, it takes a while to get here.
I'm just gonna. I threw bombs.
Yeah, you got.
There we go. Oh, okay.
Oh, and the heart exposed.
Yeah. I just have to shoot him a whole lot.
You got one more bomb too.
Yeah, I don't think the bombs actually do it. Oh yeah.
Oh yeah, you're wrecking them.
Okay.
Look at that.
Thankfully,
all right,
it's over.
Cheers.
Okay. Cheers.
Thank you everyone for joining us on Wednesday night. Hopefully you're drinking, watching some Star Fox, thinking about statistics and all sorts of things like confirmation bias, p-tests, and network theory. Cheers. Thank you for joining us. So Reese's Pieces has redeemed request a factoid. Drop a knowledge bomb on the audience. Do a D.D. Carl Sagan in preparation.
So, I guess the factoid that, so we kind of went back and forth about how to phrase this as one of these so-called predictions, but we couldn't get it down to the characters that we needed, so perhaps we'll use this one as a factoid. But so one of the more, I think, surprising results that you'll find in kind of introductory probability, advanced introductory probability. So it's kind of funny. In statistics, we have courses with the title Introduction in the course title at the 1,000, 2,000, 3,000, 4,000, 5,000, and 6,000 level. But so it's kind of a misnomer to say introductory course in probability, but you can consider a game where Ken and I here flip a coin. And if we get a heads, I win. And if it's a tails, he wins. If it's a fair coin, we're equally likely to win or lose. So you might say, okay, well, who do you expect to be ahead, to lead, to win? Either of us. It's either of us win, right? We each have an equal chance of winning or losing the game. But there's an interesting result in probability. Oh, I have to do this factoid while doing this level.
You chose the wrong factoid.
Oh my gosh. Oh my gosh.
Infinite lives.
Yeah.
Commit to the factoid.
Yeah. But there's an interesting result in probability where if you start tracking who's winning, and you say, okay, well, what percentage of the time am I ahead or are you ahead? Actually bias emerges in a very interesting way. So let me make this concrete for you all. Say it's a heads, so I win. I'm in the lead. Now we flip a second coin and it's tails. Now Ken has 1 point and I have 1 point. It's tied. Nobody's in the lead. Now it comes up tails again. Ken's in the lead. It comes up tails again. Ken's in the lead. So now Ken's been in the lead. I think I've lost track, but 2 turns now, and I've been in the lead 1 turn. So 50% of the time Ken's in the lead, and 25% of the time I've been in the lead, and 25% of the time nobody's been in the lead. Now, for fair games, you would expect that we each have an equally likely chance of winning. And so some people incorrectly assume, well, what percentage of the time do I expect to be in the lead, and do you expect to be in the lead? Some people apply the law of large numbers or the law of averages, however you want to think about it, to say, well, that should tend to 1/2. If you play the game enough, you would expect to see, 50% you're in the lead, 50% I'm in the lead. But it turns out that this is not how reality works, and there's something called an arc sine distribution, which is the limiting distribution for this. And what it basically comes down to is this: the probability, no matter how long we play this game, the probability that one of us has been in the lead 75% or more of the time is 2/3. So over half the time, one of us, we run this experiment, 50%, 2/3 probability. So if we play this game every day, we would say two-thirds of the days, we would expect 2/3 of the days, one of us to be in the lead 75% of the time or more. And it's just a really interesting result that I think kind of defies your expectation, because you say it's a fair game. Why would one person be leading so much more than someone else? And it's called long leads is the problem title.
Long leads.
Long leads.
Probably has
long leads. It's
Wikipedia
famous. It's in
page.
Feller's probability book. Yeah. So you want to probably Google probability long leads. I don't know if you can start to throw coin flips, arc sine distribution.
Probability of long leads.
Yeah, probability of
Wolfram
long
Demonstrations Project. That's
Oh,
fun.
fun. Okay, I need to die. I need to get my ship reset.
So that's long tail distribution? That related?
So long, kind of, but the probability, so the long leads is, so what they're showing you is that's the arc sine distribution. So there seems to be a kind of a slider. So if you slide that thing to the right a whole bunch, it's going to start to, so it's going to start, so the limiting distribution is arc sine. So as a percentage of the time you win, what it's telling you is that there's a significant portion of probability mass near 0 and 1. So 0.25 is the percentage of time I'm in the lead is 25%. So the probability of that I'm in the lead for less than 25% of the time is actually 1/3. If you in the limit. But anyway.
No, it's an interesting counterintuitive outcome.
Yeah. It's not something you would expect.
I never understand these games, to be honest. Is that Star Fox 64 or the coin toss game?
I'm not sure I'm understanding Star Fox right now.
Oh, don't worry. We can bust out infinite energy if you want to. This is a non-trivial level.
I forgot what I
obviously.
have to do here. I don't actually remember what I need to do on this level. Aim for the 6. Oh, okay. Well, they tell me what I need to do. I need to aim for
Gotta
the
listen to the rules, right?
energy. All right, I got one.
There we go.
Yeah.
Deku Darling, thank you for the follow and welcome. Enjoy your standard internet units. Spend them on, I don't know, making us take a drink, requesting a factoid, unlocking some of the emotes. Yeah, welcome. We should probably do a prediction here. Which one? Well, take your time. Focus on that for now.
Should I listen to? So Scuzzbot wants to know about the Monty Hall.
Oh, that's a good. Let's go after that. What do you think about the Monty Hall problem?
So I teach it in my class, and it's a really great way to understand the value of information.
So can you explain Monty Hall to those that aren't familiar with this?
So the basic way Monty Hall works is you've got 3 doors on a game show, okay? Behind one of the doors is a prize, and I think the usual setup is there's a goat behind the other 2 doors.
I don't know why a goat,
So,
but sure.
so you want the car, right? You don't want the goat.
Unless you like goats, then your odds are in your favor.
Yeah.
But if you want the car, anyway.
And the way the game works is this. You choose a door, and Monty, the game show host, will pick one of the other 2 doors and reveal a goat. Okay? So you pick a door, and Monty shows you a goat behind one of the other 2 doors. So just to remind you all, there's 2 doors with goats and 1 door with a car. And so if you pick the door with the car, he just picks at random one of the other 2 goat doors. But if you pick one of the goats, if the door you pick has a goat behind it, then he picks the other goat door to show you. And so the Monty Hall problem, or the Monty Hall paradox, I don't know that I see it as a paradox, but the paradox, as it were, is that your dominant strategy is to switch the door. So after he shows you one of the goats, he says, do you want to change your door? And you have a choice to stick with your original door or to pick the new door. And I forget the probability. I think it's 2/3. But the chance you win if you switch is 2/3. And this throws people for a loop because they say, no, there's 3 doors, one of them wins, the chance is 1/3. But that requires no knowledge. You don't know anything other than there's 2 goats and 1 car. And the way you resolve this paradox is by thinking about the value of information. Once Monty reveals one of the goats, he's told you something about the system. He said, this door does not have a goat. Or sorry, this door does not have a car. And it turns out that is really, that has value. And it changes the odds. It's now not, 1/3 chance. You actually are better off now swapping than not swapping. And you either have to show this in simulation or just, as I do in my class, just do the math. I don't know that I could convince you of this just using my voice while playing Starfield right now.
No worries.
But the intuitive answer is that there's value. So think about you're a consultant at a company and you value some merger to be $2 million, making it up.
Yeah.
Whatever it is, $2 million. But now say that there was a lawsuit that was going to be brought against one of the companies and that was going to be merged. And now the merger is worth, negative $5 million. In other words, you lose money on this merger, or by purchasing or incorporating, however you want to think about it. And if you know that there's no lawsuit, then the company's now worth $9 million, say. This is the value of information. Knowing that a lawsuit is or is not going to be brought against a company tells you something about its value. If you buy a company and you're saddled with expensive lawsuit, you don't want that. And so this gets at the heart of the Monty Hall problem. That knowing something about the game helps you. Knowing, and when Monty tells you, this door has a goat behind it, that gives you information that's useful to you.
And Mythbusters did a version of Monty Hall in an episode. All 20 of the volunteers played the game, stayed with the original door selection. Amateurs.
Did only 1/3 of them win?
A good question.
I think those are the I forget it, but I think it's 1/3 if you stick with your original and 2/3 if you swap.
Is it actually 2/3 if you swap?
I think it's 2/3. I forget. It's more. I don't know how much. I forget exactly.
Yeah.
I think it's 2/3, 1/3. But there's only 1 week of the year that I actually know that answer.
Mythbusters.
The week I teach it.
Yeah, no, it makes sense. So you don't use most of what we teach often. We use it when we teach it.
Well, there are certain things that, you look up. It's what I tell, my students is, it's important to know something once really well. And then from there, you know, it suffices to know where you can find it if you need to look it up again. They confirm the expected result. Oh yeah, if you can code at home in Python or R or MATLAB, it's pretty straightforward to run the experiment. And you know, famously, you know, a famous I forgot who it was. It's on the Wikipedia page, I'm sure, but a famous statistician couldn't be convinced of the result until they saw it at a simulation.
Well, simulation, I guess that makes sense. They didn't have to see it actually demonstrated live.
Yeah. Well, but the way the problem came up is I think someone wrote in. There was a journalism piece about it that started this, and people didn't believe it.
Turns out our intuition is pretty abysmal.
Our intuition is often wrong. Well, it's like we get tricked by optical illusions a lot.
Yeah.
I use that analogy. You know, if you think of how easy it is to get tricked by an optical illusion, you know, we're equally likely to get tricked by other things. You know, or we're just as likely to be tricked by other things. Or reasoning. Yeah, I'm shot down.
No. Oh, do you have to start over at the very start, or is there a checkpoint? Okay, you had it.
I don't know. I might not beat Andros.
Reese's Pieces. Think of the extreme case, 100 doors with only one car. Monty opens 98 doors with the goat and then asks if you like your original choice. That's interesting. It's a way to reframe it.
Gee, I've been saved by Fox. How swell.
I'd have to do the math. I don't know if that has the same odds.
Oh, in terms of the second choice, is it going to be 2/3 still?
Yeah. Because the problem is still that your decision is still the same.
Yeah.
But I have to sit down and work it out. I'm afraid at the end of a long day and playing a game I couldn't think about this. But I mean,
no worries. Make your students do it.
Yeah, I know. 1 out of 10 for the originals. Yeah, I think that should be right.
I like it.
So you kind of absorb the probability of the other doors having the so if each door has it 1/10, you absorb their probability. So 3 doors, I'm gonna get shot down.
You
again.
absorb their probability.
Yeah, well, I don't know. That's how I think.
That is my favorite.
So
sentence.
if it's 2/3, 1/3, they killed 1 door, so you get to absorb that probability. So 2/3 now if you switch. If they kill 98 doors, then your door still had 1/100th, and then it absorbed. I don't know if that's right.
It's the Highlander of game theory, right? It's absorbing probabilities. That's amazing. Oh, I like it. Mildly related to games. Do you have any thoughts on the stock market, and do you have any interest in playing that type of lottery?
I have an interest in retiring at a ripe old age. So yes, I'm not a risky bettor though. I believe, you know, I mean, if you look at the data, just sticking with good index funds, you'll make money over time. If you're trying to make, I don't believe in making money fast. I think that there's always risk, and I think there's a lot of survivor's bias. So to speak.
It's like anyone can do it, right? Yeah.
I do not gamble ever. I just know too much about it.
That's fair. Do you control your own portfolio, or are you just kind of
blue chips? Well, I use an index fund, and I like the index fund I have. It performs well. It's not very expensive, and you know, so that's what I do.
Yeah, you're not taking into account insider trading. That's the real rub.
Yeah. See,
become a senator or a House representative.
Poor Martha Stewart.
Yeah, exactly. What our government officials do all the time, she went to jail for. Poor Martha Stewart. I like it. All right. Scuzzbot Wotus, one of my favorite counterintuitive statistics related scenarios is rare disease testing. The number of false positives can be much higher than anticipated. Speaking of which, we talked about doing a...
Yeah.
Do you want to do this prediction?
Yeah, why not?
All right. We have not spent any of our internet points tonight. We need to, because it is time.
Internet points. It's all made up.
It's true, but it's fun.
Uh-oh, did I... No, I didn't crash it.
True versus false.
I don't know that I'm going to get past this one.
Do you want infinite energy? Because we can make that happen.
I don't know.
You want
Let's see.
2 minutes on that? Is that enough time, or should we do 5 minutes on this one?
I would defer to your judgment.
I mean, it
wouldn't
depends
know.
how long it's going to take you to explain it.
Oh, this one's very easy.
Okay, so 2 minutes?
Yeah.
All right. Have your standard internet units ready to spend. Here's the question. True positive rate equals 80%. COVID chance equals 80%. So, Jonathan, if you wouldn't mind elaborating on what that means.
So, think of a test.
Keep in mind you have 2 minutes for them to make decisions.
Okay, so think of a test. You go to get COVID tested, and the test they apply has a true positive rate of 80%. And the question here is, okay, if you test positive, does that mean there's an 80% chance you have COVID? Is basically the problem statement. I think if I say too much more, I'll end up giving it away, so I'll stop.
so that's the question. If the true positive rate, or the actual answer is 80% correct, is your chance of getting COVID 80% true or false? Throw your guesses in there now. Spend your standard internet units.
Yeah, so the true positive rate, just in case you don't know what this is it's the probability of getting a positive test given that you have the disease is equal to 80%. The question is the probability you have the disease given that you tested positive for the disease also 80%?
True or false? Throw your guesses in there right now. Use your standard internet units because they're useless everywhere else in the world. All right, sorry. Did you decide you want the energy?
I feel like I need it, otherwise we'll be here all night.
All right, I will get the cheats on.
Yeah. At least for this.
All right, infinite energy. Do you want any infinite bombs or dual lasers?
Just give
or
me
anything?
everything and to get past these guys.
All right, we're gonna do it.
Yeah, just give me everything to get past these guys. You can take it off once I'm in the hole.
All right, now you are a beast. Let's do this.
All right.
The best kind of units don't work.
Yeah. Let me just
All right, so
throw
it's
bombs
closed.
out.
Oh, 3 people said false, 0 people said true. The payout is neutral. What's the answer?
The answer's false. Well, the answer is it depends, but it's false as stated.
All right, false as stated. Do you want to elaborate?
Yeah.
Congratulations on not making any money on that bet because nobody went the opposite
Okay.
way.
Well, maybe it was too easy.
Yeah.
But the reason why is this related to the base rate fallacy is the probability you have the disease might not be 80%. If it is, then yes, these two numbers should align.
Huh.
But for most diseases, 80% of the population is not infected, right? You know, you're usually looking at a small percentage, and so the probability you have the disease is very low. Actually, it's something called prevalence, the percentage of the population with the disease. And so, if you use Bayes' rule, you can actually compute these probabilities, and you'll find that there are 3 numbers with which these probabilities matter about, are determined by. I need to kill these guys, but it's sensitivity, which is true positive rate, specificity, which is true negative rate, and prevalence. And if you know these 3 numbers, you can compute the probability you have a disease, given that you got a positive test result, and the probability that you do not have a disease if you've got a negative result. And for COVID, at least, the clearance rate, so the probability you do not have a disease, given that you tested negative, is actually quite high. It's like 99% or something. I ran the calculation a while back.
You did.
But, well, we used it in my class. It was a great example.
Well, I was going to ask.
No time like now.
When you've taken a COVID test, like you know what the stats are. Right?
Yeah.
At least to some what's publicly available, right?
Or you hope that something wasn't done incorrectly with the test.
User error.
Yeah.
Oh, yeah, good point.
You know, well, okay, I need to get this down. But it's actually really hard to get a high detection rate. And this is true for cancers. If a cancer is sufficiently rare in a population, unless the test is very, very, very good, it's hard to get a good detection probability. Because the chance you just had the disease, the so-called base rate, as it were, is sufficiently low.
That's interesting. I hadn't heard that term before, base rate.
Yeah, it's on Wikipedia. You can Google base rate fallacy and read a whole bunch of other versions of this. But
DCU Darling has requested take a drink,
Okay.
so you have infinite energy now, so it doesn't even matter. Cheers. Thank you for swinging by. Thank you for joining us for Ask a Scientist Gaming. Yeah, if you guys have any questions for a statistician, you want to know about why your intuition is wrong, Jonathan Stewart is here, happy to reveal all that goes behind statistics. So if you have any idea or questions, please throw them in chat. If you want to learn things about network theory and there was one on your webpage, I can't remember what it was. It was called Exponential Families or Polynomial. What was the term?
Exponential Families. So
What the hell is an exponential family? It's when you have 20 kids, because that's
Well, one. So it's an enormously famous class of models that's found prominence in spatial statistics, machine learning, high-dimensional statistics. I mean, everywhere. You know, statistical network analysis. It's an incredibly flexible and broad class of models. The reason it's called exponential families is because you assume that your probability distributions have kind of an exponential form. And the way they're defined, I finally got this down.
there it is. So
Okay.
you want the cheats off now?
Yeah.
It's up
Let's
to you.
make it a little challenging,
All right, sounds good.
you know.
All right, so I'll
The
turn off
infinite
the
lives
bombs.
is fine.
Now you're back to infinite lives.
Yeah.
All right.
It's just
Exponential
too
families.
easy. I mean, if I can not even look at the screen, it's like a random walk. You know, eventually you'll get home. What is it? The drunk guy walking home. Eventually he'll get home. It's a recurrent, process. Eventually, he started at home. He went out. Eventually he'll come back.
Given an infinite number of steps, he will reach home.
And it was very fun, because I saw a guy stumbling one time, and I thought,
There it is.
one step forward, two steps back. Wonder how long it'll take him to get to his car.
Oh, to view the world through your lens.
I offered them a ride home. And thankfully they took me up on
So
it.
you interviewed. You intervened.
intervened.
You screwed up your Monte Carlo simulation.
I thought, I like safety.
Yeah.
You
And you don't have an infinite number of drunk guys. So
And they don't have an infinite number of lives. And neither do I.
that makes you a good
Only
person.
only in the game.
But if you had an infinite budget and no moral qualms.
Yeah, right.
All right.
I don't know. I was trying to answer something. I get so distracted by the game, unfortunately.
DCU. I don't know how to pronounce your name. How would you pronounce that name right there?
Deku Darling.
Deku Darling?
I will bet you 1,000,000 imaginary points.
That's Deku Darling.
bet
Spell
you
it out
anything.
phonetically in chat. But their question is, what is the best project you have worked on?
The best
In your opinion, not in terms of like citations or anything like that. What did you care the most or find the most intriguing?
Well, I'm trying to think. I know the answer. It's not a hard question for me.
How do you explain it?
I'm just trying to think of, So I there was a lot of doubt in the literature and people, the class of models that I study. I've devoted, a decade of my life to training to do this now, I guess. The class of models that I study that I really love, these exponential family models of random graphs, they're very finicky models. And so there was some research in the early 2010s, and I guess it started in the late 90s and early 2000s, that said, oh, these models don't behave well. They're doing all these things we don't want them to do. And unfortunately, they got a bad reputation as being flawed. But over the last, I guess, 6 years, my collaborators and I have spent an enormous amount of effort to kind of fix these opinions by devoting an enormous amount of time to proving theory that says, no, they're only flawed if you don't, do it right. But when you do it right, they're super great. And the most informal way I can put that is not to bore you all to tears.
I mean, that's a commitment going against the grain, against the public opinion.
And we had a paper in review for 3.5 years. So I guess we spent a year on it, and then it was under review for 9 months. Then we spent 8 months revising it, and then it was under review for another 7 months. And anyway, so the total time was like 3.5 years.
Jeez.
But it was published in our top journal, the Annals of Statistics, and I would say that was my most rewarding, is when that finally got accepted and we said, no, we've done it. The message is going to get out there now.
And so has that been well received?
Yes, I think so. Well,
I mean,
it in other words got me a job. So, I think so.
Good enough. No one at FSU hated it enough not to give you a job. So we'll take that as a victory.
Yeah.
I mean, that's a fun uphill battle. So when reviews come back for you, so like as an experimentalist, they'll be like, did you think of this? Did you measure this? Can you measure that? What does it come back? What does a reviewer comment come back to you that takes you 9 months to deal with?
Well, some of the same stuff, right? Because they'll say, well, what if you tried this? Or what if you did this? Or, do you need that assumption? What if do you have to assume that? Mm-hmm. We don't, it would be better if you didn't, but...
So then you redo the simulation, changing those variables?
So for simulations, you redo the simulations, you relax assumptions, you play, basically. Simulations are just a playground.
Yeah.
And, for theory, though, sometimes you'll say, well, I'm not convinced by this part of the proof. Can you do a better job on this, or can you make this a little more clear? Can you try? Are you sure this is true? Or I think you've taken this fact for granted. I think it can't be taken for granted. Things like that. And then you have to address those. So add and prove new things. They might say, well, you proved this, but what about this? Is it true in this scenario? So it's mathematical proof is what it is. Theorem proof. And so when you're talking about things like that, sometimes it is much like what you would get. Where it's, well, what if you tried this, or what if you did this?
Yeah. What is this? What if you did that? Look at that guy.
What if you did?
Look at what they've done with these polynomials.
Yeah.
Is this the final boss?
Yeah.
Oh, wow.
On the although this isn't technically, I went the easy path, so this isn't technically Andros. It's a robot. I'm ruining it for everybody.
Well, now you guys got to go play this by yourselves.
Oh, he got me.
He just ate you.
Yeah, he chews you and spits you out.
Only a minor health loss.
I think I'm supposed to shoot a bomb. I forgot. Oh, yeah, and then your ship gets totally wonked.
Oh, now you're drugged out?
Yeah, now you lost your wings. You get the laser.
Oh man, I'm really glad you chose Star Fox. I love this game. This is
I still know all of the.
Oh, nice.
Yeah, so if you have a bomb, you just throw a bomb in his face, and then you get to blast his hands, and at some point these are supposed to die.
Yeah.
They don't seem to want to do that. Oh gosh. What is this kind of... I'm afraid I'm going to need you to read that one.
Yeah, no worries. You don't have to do it. So Darling wants to know, how does this kind of review work at this level? What I mean is, who is reviewing these papers and what credibility do they have?
So the way the review process works is there's an editorial board. So when you submit a paper, editors of the journal, who are established senior, and usually senior, and very well respected. That's the hope. they will assign an associate editor to the paper, who will usually do kind of an initial review to see if it is in the scope of the journal, if they're interested in, publishing it. And if they are, then they send it out to reviewers and they recruit reviewers. And there can be a lot of variability in reviewers. Some reviewers are nice, some reviewers are mean, some reviewers are good, and some reviewers do a bad job. So there's a lot of risk. So this is probably the thing that most people find very frustrating about academia, is that there can be an enormous amount of variability with reviewers. And a good review will help you, a bad review will hurt you, so to speak. If it's very bad, then, usually... Oh, I forgot I can shoot his eyes. If it's very bad, then usually the editors or, review... If they do a bad job, I mean, the editorial board's supposed to kind of intervene. Sometimes they do that, sometimes they don't. But in terms of how they find people to review this, they're experts in the field. So they're usually people who have submitted to the journal or published in the journal or are well known in the field and work on similar stuff. So they will know they're probably people you're citing in the paper, because there's the community's not that large. And so I hope does that answer your question? Sorry, I'm trying to kill this crazy guy while organizing my thoughts. Yeah. Yeah, but they're always experts in the field, and especially at the top journals. I generally try and take if a journal invites me to review, I generally try. But for top journals, you almost never say no. Because it's service, and it's very, very important service. If they're asking you, it's because they need people to do it, and you want to do a good job. You don't want bad people to review papers.
And you want the editors to like you.
That doesn't hurt.
There's a social aspect to this problem.
Oh gosh, I might need my cheat codes back on for this.
All right, we can definitely do that. Want them not on now, or do you want to wait till the...
I'm gonna die here anyway. It's gonna eat me. So I'm out.
Beautiful polynomial, or beautiful polygons. All right.
Yeah, boom.
All right, you want everything? We'll go beast mode.
Yeah.
It's almost cheating with too many bombs, but there we go. All right, now you should be good. We'll see, unless it doesn't work against this guy.
I've lost my wings, but I still have to,
So, I mean, you had a paper under review for like 7 to 9 months, right?
Yeah.
Is that what you said? Yeah. Like, is somebody...
9 months the first time.
Does somebody actually try to simulate the data and reproduce things, or how does that...
No,
why does that take so long?
These papers are very long. So we have a paper that we just got back now. We just... the review time actually was much shorter. It was still like 7 months or 6 months or something. But, the paper is 30 pages, but the appendix, I think on this paper, was 59 or 60 pages. And the appendix is all mathematical proof. Because there's, sometimes these things are just... the proofs are just very long. And and so... if you want to seriously review the paper, you need to get into the meat.
Yeah.
And it takes a long time, and you have to think the people reviewing this are going to be, top people in the field, and they're very busy. And so sometimes, they just need enormous amounts of time to review it, and that's unfortunately kind of the nature of the beast, I think.
So how often do you review then?
How often do I review?
Yeah.
Well, I guess I do probably one a month, maybe one every 2 months. So I imagine I'll start to get more as I become more and more senior. So this is only my second year as an assistant professor at Florida State. But I guess I probably do 5 to 7 a year, maybe. But some of them are fast. Like some of them I do in a month because the papers are not that hard to read. Some of the papers, I can do in a day. Most people actually probably don't spend more than a day on unless it's a very long, very hard paper. it's about finding the time to just do it and write a good report.
Yeah.
That's the problem.
Yeah.
So you need a month, they have to give you a month to do it because you need to find, okay, what weekend am I going to sit down and actually read this and try and understand it and write good suggestions, etc. Oh, I can blow them up now.
Yeah, I know. I've definitely gotten to the point where I have to start saying no to reviews. It's hard, especially as an assistant professor, because you're like, I want to help, I want to be on this person's good side, and it just, for me at this point, I probably review 4 or 5 a month, so I'm like once a week reviewing something, but I also love it because that forces me to read literature. So like that's the only way I sit down, and other than writing proposals, to sit down and actually read, cutting edge stuff. Sometimes it's absolute garbage, and so it goes.
Fortunately, I like most of the things I've been asked to review. There's been a couple things I was like, but I'm generally a pretty positive person.
Yeah.
But sometimes something isn't. It's not right for the journal. It doesn't meet the journal standards, and so sometimes you just have to suggest that they go somewhere else with it.
Reese's Pieces, how common is it to have a critique of the proofs? Do they usually critique the proofs methods or presentation of the proofs?
Yes.
So they'll actually go through line by line and make sure your steps are coherent.
It depends on the reviewer. But yes, sometimes they will go. Like, sometimes it's not feasible to check every result, but you check the main results. At the end of the day, you're not responsible as a reviewer for whether what is in the paper is right. You're not an author. Your name's not on it. So if someone puts out something that's wrong or problematic, and mistakes happen. I mean, there's, famous people have, had errors in their proofs in famous papers and famous journals, and, they got another paper in the journal correcting it. So, it's
twice as many citations.
Yeah. Just because you see it published in a journal and it says theorem proof doesn't mean that it's, correct. It just means it's probably correct. It's been checked probably by at least 3 or 4 or 5 experts very well. The people who wrote it, the people who reviewed it probably checked the main results. But, if you're talking about minor results that are very complicated, I don't know that those are always checked. I can't say. It depends. Like, I've been asked to review things that it's not in my field, and so I don't comment on certain things. I was clearly invited to review it just because I could basically check the proofs. I don't, and I even say to the editors, I say, this is not in my field. I don't know if this is an interesting problem. Oh, do I have to shoot his eyes? Thanks.
Reese's Pieces, do you know the game, or is this just based on observation?
Don't.
Oh,
or maybe
I was going to say that was taking a while to kill him.
Yeah, I was like, I've hit him with like 8 bombs.
Oh no, look at that.
Yeah. So now he's gonna chomp.
Open set.
Thank you.
This is why one should just make proofs too long to check, like the ABC conjecture.
You'll get it rejected. I mean, the proofs are already long, but if someone can't read the proof, that's problematic, and it's very hard actually to write proofs that people can read very easily. We try, but sometimes.
So there's a presentation standard on proofs and how it should be, or is that not?
I don't know if there's a standard, because different people have different ways of proving things. Some proofs are more concise. They're also sometimes harder to read. Some proofs are more wordy, and the goal is to kind of write, to explain and teach. And I think I fall closer to that latter category in my writing, because I write the proof like I would want to read it if I were someone else.
It's very courteous of you as an author.
But some people might not like that. They might prefer simpler, more to the point proofs.
So is that the end? You did it?
Yep, that's it.
All right, we got some Bowser GGs.
Right?
An hour and a half. Speedrun record is 22 minutes.
Okay. So I'm not going to be on a speed run.
Cheers. Not yet. You got to commit to it.
Yeah, so cheers. Yeah.
Oh, we didn't actually say what we're drinking. What are we drinking today? We'll show it in chat. So it's it's Bitburger. It's German. It's kind of hard to read on the lighting.
Very shiny.
Basically, Jonathan told me, I'll do a pale ale or a Pilsner or whatever. I don't really care. So I go into Beer City and I say, what's the first Pilsner I haven't tried? And the answer is Bitburger. Apparently, this is the beer of choice for German hooligans. So we thought we'd try it for Ask a Scientist Gaming. So if you guys are interested, it's okay.
It's okay.
I don't have any strong opinions for or against this particular beer.
I'm pretty, it's fine. Yeah, I think that's definitely true.
There are definitely some authors where it takes N words to be perfectly clear, and they use N minus one.
It's rooted, right? People criticize the text because everything's so bare bones, but I mean sometimes that's a nice style, If the author does everything for you, what do you learn? You're just reading. Sometimes it's nice for textbooks to leave you wondering, but I don't know. I guess there's a balance there.
All right, Star Fox done. Congratulations, victory.
Yeah.
20 some years later, you got your vengeance. Did you beat this when you were younger?
Oh, dozens of times.
Okay, so
this was one path. You can go through all the other paths. I wouldn't know how to do that now.
No worries. Commit to the speed run. All right.
The
what do you want to
careful
switch
reader
to?
will observe. Yeah.
Mario Kart or Smash Brothers? What do you want to do?
Mario Kart or Smash Brothers? How about Mario Kart? Smash Brothers is a little intense like this. You got to constantly keep on your toes.
Yeah.
If I drive into a wall, who cares?
I promise you our viewership does not. They're more interested in talking about statistics, p-test proofs, all the exciting aspects of what we do. The careful reader will observe.
That's always so funny to me.
Man, one of my pet peeves when I'm reviewing a paper is when someone says, clearly you can see, or like, obviously, blah, blah, blah. And it's a judgment of your reader. And it's arrogant and it's condescending, and it makes me very angry when people do it.
Yeah. A major discovered for MP60. Oh, so this one?
Yeah. No, the recent record, it was broken like a week ago.
Wow.
I don't remember the speedrunner, but he's an absolute beast. Like, you can beat this first race in like 20 seconds. Yeah, you basically loophole off the side of the map and you can do a lap without doing an entire lap. Yoshi, why Yoshi?
Well, I would pick Waluigi, but he's not in this one. And I like Yoshi. Yoshi's nice. I don't know which one. I'm going to do the Mushroom Cup.
Yeah. Start in race one.
Yeah.
All right, we'll let you get a race in before we start betting on Mario Kart races.
I forgot how to start. I think I have to push A.
It's the blue button
lane.
at the green, yep.
Yeah, at the green. Okay. Wow.
Shy Guy is my favorite in the new ones. Yeah, Shy Guy is not in the...
terrific.
Yeah. I don't think you can drive as Shy Guy in this one. A little bit limited in scope. Well, make him pay for it.
Uh-oh. Oh, no.
Oh, Carl Jobst had a new Mario Kart speedrun. I've dove deep into the speedrunning community, and there's certain people that make really good YouTube videos explaining exactly how glitches work and how they manipulate the game. And this Scuzzbot just put a link in there to YouTube of one of these videos. Nothing ruined this game like realizing your character is at a fixed point on the screen. Like a metaphor for your life not going anywhere, really. Thank you, Reese's Pieces. All right. So I have one question. This is for me. This is one of my favorite. I've watched a lot of movies. I've rated something like over 5,000 on Netflix because that's what I do. We've been cord cutters for like 2 decades now.
Wow.
But anyway, the question is, what movie or TV show gets your discipline right? What gets it wrong? So this could be in the broadest sense. This could be exacting on statistics. What are your thoughts? This could be even a Monty Hall question. This could be gambling, stock market, Moneyball.
Yeah. What gets it right and what gets it wrong? I'm trying to think of a movie or a show where statistics was used in a real way. I'd almost think the true crime. It's got to be something in true crime that gets it totally wrong. I don't know. You know, I don't know. That's just my suspicion, but I don't watch enough of that.
Yeah. I mean, so you talked about Nash equilibrium earlier,
Yeah.
like A Beautiful Mind. It's a
Yeah, but they-
economic statistic.
They got that right? They did a good job with that. I think.
Yeah, I guess they got the schizophrenia wrong, but like in terms of the explanations,
Well, that wouldn't make for good television.
yeah, exactly. Actual having reality.
Yeah.
Does the janitor in the math department solve all the problems left on the board?
Not really.
That doesn't happen in statistics department.
No. You know, we're usually
Have
happy
you
if we
tried? Whiteboard in the hallway.
we actually do in the statistics building. We actually do have chalkboards in the hallway.
That's amazing.
But they're littered with nonsense. Nothing of value, I'm afraid.
That's fair.
I don't know. That's a really hard question. If you had given it to me before, I could have thought about it. I don't know if I have an answer. You know, because if you're like a physicist, you know, especially an astrophysicist, then you know, pick one of the many space movies.
Yeah.
And you know, oh, what's his name? Oh, he gave my commencement speech too. I should know this. The famous guy.
Neil deGrasse
Yes,
Tyson.
Neil deGrasse Tyson. He goes off on some of these movies.
Yeah.
Oh, I have to hit a point. As being informed by psychics, yeah. So, you know, psychics, anything with psychics, because it's just confirmation bias to the extreme. That's my pick. Anything with psychics.
What if they're actual psychics, though?
If they're actual psychics?
Yes, they actually have a superpower.
What was the Mad TV skit where they...
Mad TV. Wow,
Yeah.
that brings me back.
Yeah. There was national tragedy,
nice.
and they call into Cleo, one of this old
Yeah.
cool
The
people, and they say, you know,
infomercial, Miss
oh,
Cleo.
were you working on, you know, September 9th? You didn't get nothing? You know, it was I forget how they do it. I forgot who was involved in that, but you know, whenever I think of psychics, I think of that. Like,
So have you seen Moneyball?
haven't.
I think it's worth a watch, if for nothing else than the nerd is like the hero. Like, we get a rare opportunity to see ourselves on screen as being the winner. Like, I love Beautiful Mind, like, you know, a Good Will Hunting kind of thing. And that one seems like an honest portrayal. I haven't read enough of the original books or know enough about Moneyball, but it seems like an honest portrayal. Miss Cleo. What about, did you see the movie 21? It was about the MIT blackjack team.
I didn't.
So that's one of the few movies where I've seen them invoke the Monty Hall problem in a classroom scenario. And the teacher was so impressed with his ability to answer correctly that they invited him to play poker with the card counting team. So
Very interesting.
it might be worth a watch.
Yeah.
That's not true. It's not. But you get a Monte Carlo or a Monty Hall. So,
Okay, so it looks like I blasted through this one. Ooh, I win. Yeah, the types of movies I really like to watch. I watch a lot of action movies. I like, you know, sci-fi and fantasy. Big fan of Lord of the Rings, even after all these years. You know, I like those. I do like some dramas. So I think No Country for Old Men is my favorite movie to date. Maybe. It's a toss-up with Lord of the Rings, maybe, but I do love No Country for Old Men. Really, the best villain imaginable.
that's fair.
Yeah. Just chilling.
So yeah.
Just chilling.
No. It's escapism, right? No, unrelated to work. You
Yeah.
don't have to think about it.
I don't like
fair.
watching things that are too like reality. I live reality.
And it's terrible.
It's, you know, the what is it, like, the graphics aren't good.
Yeah.
You know, the play is boring. Forgot those jokes, but
Reese's Pieces.
I didn't make it.
Unfortunately, we don't get the deleted scene where Legolas uses students' t-tests. And I demand the t-test cut. Turns out it's an extra hour of footage on the already 5-hour-long movie, so they decided to cut it. I understand.
Well, they needed to decide if who was better at killing Uruk-hai, Gimli or Legolas.
I like it.
Uh-oh, I hit a bad one.
All right, 9:45. We've been at it an hour and 45 minutes. You're on to Mario Kart. If anyone has questions, my guest today is Jonathan Stewart. He's a statistician. He works with statistics, theories regarding network sciences, big data, and is happy to answer any questions you have on statistics. Teaches a number of classes, all of them introduction to something, which goes through 100 to 400 or 1,000 to 4,000 level classes. But yeah, he's happy to answer questions, so throw those in chat right now. Oof.
Yeah, we always... Why statistics?
What's that?
Why statistics? That's an interesting question.
You can read that tone however you're like, why statistics? Or why statistics?
So for me, I got into statistics. Are you involved with the new data science program at FSU? Well, let me answer one at a time.
Yeah, start with why statistics.
So my history in getting into statistics is a bit peculiar, actually. I actually, when I was applying for undergrad institutions, I applied to Oberlin Conservatory, Cleveland Institute of Music, Peabody Institute of Music, Rice University, where I got my degrees, but the Shepherd School. So in other words, if you're wondering why I'm saying conservatories for music, because I enrolled as a performance major for viola. So I originally was intending to be a musician. And then in 2009, something happened, which made a lot of people my age at the time reconsider their futures. I'm, of course, referencing the financial crisis, which we are still feeling the effects of.
Wow.
And so I made a really hard decision. I said, maybe I'll try something else besides music. Because I said, do I have 40 years at this? In 40 years, do I think that this is going to be stable? And I didn't know. And, it was a hard question to ask yourself. But, ultimately I said, do I think I would be equally happy doing something else? At least equally happy. And my answer to that question was yes. And so I tried a bunch of things. Economics, I TA'd microecon for 3 years at Rice, or 2.5, something like that. Many semesters. And I took statistics and math courses, and Hadley Wickham really got me into statistics. He was at Rice at the time. This is the race with the big new skip. Yeah. Well, I'm not going to know what that skip is.
Well, apparently you have to go down the railroad tracks and hit a pixel perfect something at the right frame to skip the entire map. At
pixel
amazing.
Perfect, you got me.
Yeah.
That's
it's
not gonna
pixel
happen.
and frame perfect, so it's 1/60th of a second you have to hit. It's
oh my gosh.
Yeah. No, it's a trial and error endeavor. I don't think it's that exact, but I'll send you the video.
Wow. But that's why statistics, I just fell in love with the way you think about the world, because we're so used in science to think of things as certain. But the whole point of science is because it's not certain. If it were certain, when we knew what the answer was, we wouldn't be doing the experiment. Nobody studies things that we know, right? Mm-hmm. We study things we don't know with the goal of learning something new. And embedded in this is the idea that, there's something that we can't predict or we don't know.
Nice shot. Oh.
Yeah, I'm much better at this game, I think. Although I feel a little bit like a drunk driver because it's so sensitive on the joystick. So I keep going off-road and swerving.
No worries. This is the first time we've used the Nintendo 64 controller, so you're testing it out for the first time.
Do I have a thing? Oh, I do.
So that's interesting. Music was your route.
For 10 years, I trained to be a classical musician, and then for 10 years, I trained to be a statistician.
So Dawn Carr was she's a professor I think she's in sociology, but she was also a musician. and she actually had, it was like a tooth surgery or something like that actually damaged a nerve in her neck. And she was reflecting on it as being a good thing because it made her change careers, basically. 'Cause she had the same concern, not necessarily the financial crisis, but this idea of, you know, you're a gig worker as a musician. Like, you spend your entire life basically, you're going to play music for rich people at their will. And she was not comfortable with that. So it's kind of crazy that similar conclusion, different pathways through. Pulls out the win. Look at that. Well done.
Yeah, there we go. Yoshi in first.
All right, so the next question is by A. Rob. Are you involved with the new data science program at FSU, or data science initiative? Right? Is it officially a program?
Well, I think there's a lot of questions as to what that will look like. And at the junior level, I'm not involved in those conversations. I would like to get involved. You know, I think it's fun to get involved in things, you know, as it's appropriate. You know, certain things require a lot of time, and it's, you know, something that in your pre-tenure years is you shouldn't do. Oh, I guess this is the victory. This is the ending. So I guess, yay, we won. Okay.
No, GG's.
But
well done, drunk Bowser.
I was like, oh, I need to be driving now. But you know, I think, you know, like, for example, the 5th floor of the statistics building is not renovated. The first floor, 4 floors are renovated. They're very nice. We're very happy to have the entire building. A lot of space, and we're going to be hiring 3 assistant professors this year. So we're growing with the data initiative. I know computer science and other people, lots of hires are being new hires and new faculty lines are being created to accommodate these new data science initiatives. But I think it's not clear to what degree anyone's going to be involved with it because it is still so new. It's possible that I could end up teaching a course that's, you know, part of it. I can't say for sure what courses will be included in that and what won't.
So chemistry, we're looking to hire in that initiative, like data sciences in terms of like machine learning and AI for chemistry related so-and-sos. So you took second place there. Are you going to do another one?
I could, should I?
Yeah, we could do at least one more. It depends on, do you want to do another prediction? I'd go with this one because that's kind of fun.
Okay.
All right, are you guys ready for a prediction?
Yeah.
So we're going to do the 6 degrees of Kevin Bacon, but inside the mathematics statistics world, which is kind of fun. I didn't know this existed, but apparently this is common in your community.
It's a fun thing.
All right,
it's a fun fact.
2 minutes. Here it is. Jonathan's Erdos number. Erdos? How do you pronounce the name?
I butcher it. I just say Erdos. But
Erdos number.
Erdos,
so what is an Erdos
I think
number?
Is the correct pronunciation. So there's a very famous mathematician, Paul Erdős, or Erdos, as I usually say, and he's kind of, you can think of him as being the founder of graph theory in a sense. You know,
so you have 2 minutes. Go.
Random graphs, definitely. And so, you know, what some of the work he did in 59 was about random graphs and characterize, which is what I study, networks, random networks. And so they came up with a number, and it's a collaboration network. It says, your Erdős number is the length of the shortest path between you and Erdős in the collaboration, in the mathematical collaboration network. So you can think of all the possible people who could have written a paper.
So you have to go faster. We have 2 minutes for them to answer.
Sorry.
No pressure.
So it's the length of the shortest path. So, you know, if you have a co-author who has a co-author who has a co-author who has a co-author who wrote a paper with Erdős, you have an Erdős number. And the number is how many people do you have to go through to get to him with papers. So I have one.
So you guys have about 30 seconds. The question is, what is Jonathan's Erdős number?
Yeah.
How many steps between him and co-publishing with Erdős? Is the answer 4 or 5?
Thank you.
No worries. I should have let you explain before I started the countdown.
Yeah, well, I'm really appreciating the challenge of trying to focus on playing a game while organizing your thoughts.
10 seconds, throw your guesses in there now. Spend your standard internet units. Yeah. There's no possible way they could know this answer. This is entirely guessing. Okay. Unless they're playing some kind of game theory where you would do a high-low on this.
Or they look it up.
Or they look it up.
Well, I think they need to be on campus or somewhere because Math SciNet is subscription based, as I recently found out.
All right, so what is your Erdos number?
What is my Erdos number? Let's see. Do I tell it now?
Yep, it's time.
All right. Mine is 5.
All right, those of you that got 5, congratulations. Enjoy your standard internet units.
So if I borrow, because I forget the lower path, so if you start at Paul Erdos, he wrote a paper with Jansen, who wrote a paper with Nowitzki, who wrote a paper with Tom Snyders, who was the advisor to my advisor, so who wrote a paper with Michael Schweinberger, who wrote a paper with me.
Oh,
So
that
the
is
path
awesome.
length is 5.
So Math and
shortest path
Stats
length
has a 6 degrees of Erdos. I'm sure there's a network theory to describe this.
Well, but the thing is unfortunately, people don't live forever, so the numbers only go up.
Oh, good point.
So at some point, nobody's writing papers with Paul Erdos anymore,
Yeah.
and his closest collaborators in terms of path distance won't be, unfortunately, alive forever. Some of the people I mentioned, I think, are no longer living.
Yeah.
And so, the numbers only go up. So the distribution's going to change over time.
Yeah. That's really interesting. It has a Wikipedia page.
Yeah.
That's amazing. I had never heard of that. I had heard of the 6 degrees of Kevin Bacon. If you're not familiar with that, it basically says anyone in Hollywood is within, 6 co-acted movies of Kevin Bacon, which turns out to work pretty well. There used to be a website, like early internet, there was how do you connect to Kevin Bacon through various different movies. They had a pathway over and over again. All right, so your number is 5. Your student's number will be 6.
6.
And then that number will just keep increasing over time. I hadn't thought about that. I mean, it's there's the link to 6 degrees of Kevin Bacon.
Yeah. Erdos. Thank you. Yeah.
Erdos.
Someone gave me the.
Is that actually correct? All right, so OpenSet has a question.
Okay.
One of my former students just started his master's in statistics and is finding the program a lot easier than expected. So I was wondering if there's any general advice Dr. Stewart would pass along to students in that position. He's attending Columbia, so it's a little surprising to me that it seems easy to him.
Well, my first question is maybe he's just a smart guy. Is it actually that the program's easy, or is it that he's just a smart guy? Or
Survivor bias.
Yeah. One of my friends had a math undergraduate degree in graduate school, and she was, she found the classes to be, relatively easy for the most part. She kind of breezed through the coursework. So, if someone's, is very well trained, they might.
Explosive
Yeah,
snowmen.
why
That
are the
was harsh.
snowmen?
What is... That's just cruel. Anyway.
So that, but if they're doing a master's degree and they're finding, I guess the question is it a thesis master's? Is it, a professional master's where they're just taking coursework? It might be that the courses just aren't really challenging. They could take other courses. I know Columbia Stat has hard courses. They could, take some PhD courses, or maybe they're interested in doing a PhD. Maybe, a master's isn't challenging enough for them. It really, that whether to do a PhD depends on their long-term goals and interests. But I think if you're learning something useful and you're finding it easy, I wouldn't complain too much. As long as you're learning good things.
Yeah, I guess if they're going for a PhD and they have to do actual research, courses being easy is great, right? Because you can commit to other things outside of that. If all you're doing is coursework, that's probably not the best circumstance.
Yeah.
So that's interesting. So when you get graduate students applying for statistics, these could be people that have a background in mathematics, statistics, economics, philosophy might be applicable. Do you accept those domains?
I'm not on the admissions committee, so let me be clear. I'm not on the admissions committee. Don't email me. I have no control. I have no control. But generally speaking, I think you try and look at someone's potential. just because someone has an extraordinary math background, that just means that they'll probably do well in the courses. Research is not like a course. You know, there are people who ace qualifying exams and never produce research that's worth even mentioning, unfortunately, because it's a totally different skill set. And I think there's some correlation. You need to know things to be able to do research well, and you need to be able to learn well to do research. But, you know, I don't consider myself an exceptional test taker, you know. I do well, but, you know, I don't think, you know, I'm an excellent test taker, you know. And it turns out that taking tests doesn't help me do my research. What I'm good at is thinking about important problems for a long period of time. It's a really long period of time, you know, months and months.
3.5 years.
Well, you know, when they're reviewing it, you work on something else. But, you know, so for the 9 months they're looking at it, you look at something, you work on something else. But
well, what's the most surprising applicant you've had and accepted, or you?
I haven't been on the. I don't.
I mean, you see the packages when accepting students, or how does that work?
No, I don't look at that.
Because in chemistry we get like biology, biochemists, we get chemical engineers, material scientists, and sometimes it's just like, yeah, you seem competent.
Sometimes you get weird things, you know. Yeah, I couldn't say, you know, I mean, you know, someone could have an odd double major. Like I chose not to pursue the music degree at all in any capacity.
Oh, really? You didn't even get a minor or take any of it?
No. And so, you know, I mean, some people might have an odd double major. You think, huh, that's interesting, like art history or something. And, you know, maybe they're just interested in that, you know, and they enjoy the opportunity to study it. But I don't know. I think, you know, most of the students that I encounter in the graduate program, they have very standard, you know, they got a degree in statistics, mathematics, computer science, you know, one of the big three, so to speak. And, you know, that's that.
I mean, those are very different things.
They're very different.
Like, what student? I guess you'd want a cross section of all of them potentially for different things. But what's your favorite?
Yeah.
Someone to join your group.
It depends. You know, I think the most important thing is that someone can learn and learn quickly and well, and that they're motivated. To me, it's not really what you know; it's what you can learn. Because I guarantee you, nobody teaches statistical network analysis in you know, classical statistics courses. You have to you only really see it if you take basically a course on it. And I guess at some point I'll have to create something like that for the department. But you know, so when people, you know, I interview students to take, whether I'll take them as a PhD student, you know, I ask them, I say, what do you know about statistical network analysis? And they'll usually have looked at my papers, but, you know, they'll sheepishly say, you know, not very much. And I go, yeah, I understand. When I started, I didn't know anything about it.
But even that, I respect that student way more than the one that pretends to know it. Like, there's immediate red flags in that conversation.
I'm very good at finding out if people actually know what they're talking about in my field.
Yeah.
Because you can find, you know, you'll ask them, okay, well, what do you know?
Yeah.
You'll find out very quickly they really don't know much.
Yeah. But that's a character test. I mean, that tells you something about them, their honesty, their ability to learn. Like, I don't know.
And for some people, especially the students who want to go into industry, because the reason we have so many PhD students and so many PhD students who are paying to be a PhD student is because there are good jobs in industry that want the skill sets they have. And, you know, some of them say, you know, like, they're not really what they work on. They're not so picky about it as long as they like it. What they want is a PhD. So they want to do the research. They want to get the degree. So, you know, they came to me because they liked me or they liked the work. You know, they you know, as a child didn't dream, I'm going to be a statistical network analyst, you know, or a social network analyst when I grow up. You know?
That's pretty fun. I mean, it's interesting to hear you say that, because I have the same position. Like, I'll take a motivated English major over a chemistry expert that's lazy. Like,
Yeah.
because what you're going to learn in grad school, what you're going to do in grad school is very different than classwork.
And, I think a lot of people find statistics daunting, and computer science, all this data science, stuff, daunting perhaps. But, I like to remind some of my students that, mainly the undergrad students that might become unmotivated or sad at a bad test score. When I left music, I wasn't the best kid in the room. I was sitting next, I went to a very good undergraduate institution, and I was sitting next to people who were, math Olympiad champions and all that stuff. They spent, high school preparing to be an undergraduate student at a good university, studying science and math. I studied to be a musician, and there's learning curves to things. There's learning curves to everything, to research, to, to learning new skills, like a new programming language. I had to teach myself C++ in graduate school. There's a lot of times when you start a project or something and you don't have the skills you need, but you have to acquire them, and usually very quickly. And that's the real skill, I think, and the real secret to success in a graduate program is how can you identify the skills you need, the skills you don't have, and how can you get them quickly?
Yeah, acquire those skills as quickly as possible. No, that's very true.
And I think it's really true. If you have to learn a new programming language, how fast can you do that? You don't have the mathematics, the background of mathematics that you need to get through your coursework. How fast can you brush up?
Yeah. That's one thing I think about. Like, if I was just to apply for a statistics graduate program and get into it, like, how well would I do? Because my skill set is literally taking on new information and learning to process it as quickly as possible. Mm-hmm. So that's something I think about. Like, well, what are my skills transferable?
Yeah.
DECU Darling, for a graduate program degree, you aren't required prereqs from your undergrad?
Depends.
Yeah.
I think if someone applied to our program with an English degree, I think we should not accept them, because I think that hill's too high, or that mountain's too tall, whatever the saying is. I'm terrible with colloquial phrases. I think that mountain's too high. Unless they for some reason have a tremendous background in statistics or mathematics for some reason, I think that's too hard. I think that's too much. There's people who have gotten degrees in, say, sociology, and then master's degrees in, statistics or something else. And, if they had a very, mathematical or statistical training in their, scientific degree, that could work. But there are certain degrees that you're not going to have the right skill set. So yes and no. I think if someone isn't an obvious fit for a program, a lot's going to be in the statements. Why are you applying to this? And I think that's important for people. If you're applying for a program, your statements matter. Like, why do you want to get into this program? What do you want to do? Why do you want to get a PhD or a master's degree? The committees look at these, and especially if a candidate's doesn't quite look right. If you look a little different, like for me, I had to explain, why do I have 30 or 40 whatever it was music credit hours, like what is this train wreck of a transcript that is like a confusing Stephen King novel.
We have I don't know, it's a point I bring up during these discussions. It's what do they have in their toolbox to bring to the table, and where did they acquire those tools?
Yeah, I think
you can learn computer programming as a computer scientist, but you can do it as a biological statistician, right? Like, if you know C++, you know C++ or whatever language, it doesn't matter how you acquired it, that tool set is there. And so if you have the tools that we think are necessary to complete graduate school, it doesn't matter what your degree was.
Yeah.
So I think it's universal across disciplines. Just, do you have the tools? Do you have what we think will make you good at that program? All right, 10:09. Anyone just joining us? It's Ask a Scientist Gaming, mediocre gameplay, expert level science. My guest tonight is Jonathan Stewart, a statistician, studies network theory and modeling dependent data and exponential families. He is happy to answer questions on any of those things, but also like things like Monty Hall problems and counterintuitive statistics. Is happy to discuss any of these things while playing Mario Kart as Mario this time.
Yeah, I've been trying to change it up each time. Ooh, the ups and downs on this one.
Wait, should we do a prediction? So you've taken second place twice in a row now. Is that right? On the overall circuit?
On the overall circuit.
You played Yoshi last time?
Yes.
Okay,
because I get distracted.
Should we do a prediction? Will you take first this time?
Will I take first?
Not just this race, but on the entire circuit.
Which one's
round?
Wario is the answer to that. Wario would be a p-hacker. Oh my god, no, am I going backwards?
Oh no, this is not a good sign.
Okay. What am I doing? Which way do I go? Okay.
Oh man, should I not put the prediction up? You have biased the outcome here.
Yeah, I just, it's information's the value of foresight, right?
Do you guys change your answer based on this outcome?
No, I'm coming.
There's a lot of rubber banding in this game. You can come back from this.
Oh, not if I blow my red shells like that. Can I get a Bowser shell?
Oh, there you go.
Here we go.
All right. So we're going to throw the prediction in there right now. So Jonathan's taken second place twice. This is the third round. Is he going to take first on this? Yes or no? So this is not just this race. This is in the entire 5-race series. Will he take first?
Will
I have faith in you. This is the game. All the reflexes are coming back. Like you're warmed up. You're ready to go.
I'm ready to go. I don't have to get tiny lasers into, Andross's
eyes. Yeah. It's pretty straightforward.
I'm so glad somebody told me that. I would just sat there throwing bombs at them.
Which was probably, when we look back at the video, it was probably like 15 minutes of shooting the mouth, but so it goes. A-Rob has redeemed Take a Drink to try to influence the outcome of this prediction.
Okay.
I'm pretty sure he probably voted no.
Well, I have to do it now because I'm in second. I'm trying to get first.
We'll let you go get through the race.
See, that seems like an unfair thing. If they could force me to take the hands off the steering wheel, so to speak.
Manipulating the outcome.
Okay,
Which Mario character was accused of p-hacking? Which one was guilty? Scott Stagg, who's in the biology department, was asked if you had a Mario character as a co-author, who would you like?
Mario character as a co-author. Oh, Luigi for sure.
Holy shit, that was his answer too.
He would do all the work. Luigi would be the perfect co-author. Because Mario doesn't do anything. Oh, I'm not going to win for instance. Mario doesn't do anything. Luigi's, the one who does all the dirty work, He'd do all the data cleaning. I mean, he'd, handle writing the, referee report.
Oh, man.
The response to the referee's report. Yeah, no, I'd get to do all the fun bits. He'd do all the horrible stuff.
Luigi is officially the favorite co-author of Ask a Scientist Gaming. You heard it here first, ladies and gentlemen.
Oh, yeah, for sure. For sure.
Not enough points in my data set. Can I donate to undo the Take a Drink? Have you guys heard about the upcoming Mario movie? Yes, I have.
A new one?
Yeah, it's going to be animated. I don't remember who the actors are, but they're all famous. It's like Jack Black playing Bowser or something.
Oh, that wasn't the final lap.
Oh,
I just blew all my shells because I thought it was the end. Uh-oh. Wait, Jack Black is Bowser. That could actually be really fun. Is he going to have a musical number?
Mario movie.
Shoot.
Uh-oh.
Got turned around.
Mario movie distracted.
I know, this is the problem.
Oh, you're under pressure now.
I'm terrible at focusing on many things at once. I need some kind of...
All right, so Chris Pratt is voicing Mario.
Okay.
Charlie Day is Luigi from Always.
Oh, is it going to be animated?
Yeah, it's going to be animated.
Okay. I mean, I was
Jack Black as Bowser.
Yeah.
Seth Rogen as Donkey Kong. Keegan-Michael Key as Toad. Fred Armistead as Cranky Kong. Sebastian Maniscalco
Can I
as
catch up to
Spike.
that guy? I wonder.
When does it come out? Mario Movie re-release. It's not second place. We're still in good place.
Yeah, well, so but that other person's quite a ways ahead. If I look at
The answer,
mini-map.
according to Google, is May 28th, 1993. If you're
The
interested
original
in the John Leguizamo version. I don't know about the new one.
That's the one where they had the weird Goombas.
The estimated debut will be holiday 2022. The studio making Despicable Me movies is making it.
Is that good or bad?
I don't like the Minion characters, but those are good stories. I
Okay.
have no problem with that. So yeah, look forward to that holiday 2022. So a year from now, a year and change from now.
Okay, so I have
All
to
right,
do it.
race one.
Drink.
Cheers, Jonathan.
Cheers.
Thank you again. Congratulations on your winning that race.
Yeah, I had
Now you
to
got
really work for that
4
one.
or 5 to go.
Yeah, I had to really work for that one.
No, that's fine. We're we're on the home stretch of Ask a Scientist Gaming. It's pressure's on for gameplay. So the betting is 1,000K each way. So it's a 1-to-2 payout for whoever wins this next one. Hey, Rob, redeem, take a drink. Take a drink. Let me check. He voted no. So he's trying to manipulate the outcome.
Oh shoot!
And he did.
No.
Scuzzbot redeems, take a drink. Oh, man.
And this is the ice one.
Yep.
Oh, I'm terrible.
Oh, that's cozy.
Yeah, prediction. How many times do I fall into the water? Because I think if I fall into the water, the cloud has
And
to save me,
1,000K
right?
betting on our channel is a non-trivial amount of points. We got believers in asset management.
Asset management.
That's clever. Does the star take out the penguins?
I think it at least makes me immune.
Oh,
No. I got hit by my own shell. So the answer is the scientist takes out the scientist. It's,
you're defeating yourself.
no. Oh my
No,
gosh.
It's fine. You got time.
But even after that, look at these clowns.
Yeah.
They can't drive.
Oh, you're already in 4th place or 5th place.
Yeah,
Plus a penguin. Look at that. 3rd.
Buckle up, buckaroos. We're going fast. Okay.
Oh, and a star power.
Star
Except you're going to fall into the water.
no, star power doesn't save you from.
Nope, you got to stay on the track. If Rob has requested a factoid. You're just being messed with at this
No.
point.
What I've been thinking is what kind of fact? I don't,
Anecdote, anything.
I
There's
like
no
to
rules
cook
on this.
a lot. One of the
Jonathan
things that,
Stewart likes to cook. That's your factoid.
but not just cook. I like to cook well, and so I, spend a lot of time looking at recipes and practicing, and like the other night I made a Japanese curry.
Wow.
Sometimes we'll make. I'm Italian, so I like a lot of pasta dishes.
Oof, a penguin cost you hard.
I know, right? Because they're big and they reverse direction, so they don't get out of your way. Oops. I need to get right behind them so I can drop it. Let me just put it there. Oh, she got it. Okay.
And the penguins are
So
ruthless.
that's a
in this
fact.
race.
I don't know if that's an interesting fact.
It's not a science factoid, but it's a personal character factoid. Oh, what's interesting is so synthetic chemistry. I don't know if you're how familiar you are with chemistry, but it's glorified cooking where you mix things together and make a new chemical. And you
Yeah, I saw
purify it.
Breaking Bad.
Exactly. That's actually a really accurate depiction of synthetic chemistry. But what happens is after people get into my position, you stop doing wet work like that is what we describe it as synthetic chemistry. And a lot of my colleagues get into cooking because of that. Like it fills that void of, making something new. And so
See, I don't know enough about chemistry and science to really get down to the level. Some people say, "Oh, well, you're very technical, so do you think about the science behind it?" No, my father was really into cooking as well. I'm from New Orleans originally, which is a food city, and a lot of it's, for me, just thinking about, I don't know how to describe it. It's almost like intuitive, like, this will work with that. And there's a level of experimentation, but, I don't think, I don't know that if I think about the chemical reactions or anything like that.
I mean, so if you ever get the chance post tenure, take general chemistry. And if you have that foundational knowledge about like what acidity means, something called colligative properties, why you add salt to make water boil hotter, it does contribute. Like I can definitely see, like Debbie watches a lot of cooking shows and I see it. Like they know this stuff. They don't know why they know it, but it definitely contributes to productive knowledge in cooking.
What's that one guy who actually breaks down the
Alton
Brown.
Yes.
I like Alton Brown a lot.
Yeah. And he does a really good job. I actually saw him live. I was a postdoc at UNC Chapel Hill, and there was a show in, I think it was at Duke, actually. So I got to see him live talking about, and he does. He breaks it down from a scientific perspective, at least as much as you can do for a popular audience. So that was pretty fun.
Oh, that's fun.
He'd be a fun guest on Ask a Scientist Gaming.
He would be very funny.
Yeah.
Well, because he does this for a living.
Yeah.
I don't
know about oh, no.
Oh, gosh. Oh, yeah, it's the cloud, yeah.
Yep.
See, the thing is he's meant to... And I got a blue shell. I still have my blue shell. Oh, wait, I thought the blue shell takes you to the front.
No, blue shell takes out the first place player.
Oh, that's right.
Yep, it hunts them down.
That's a new...
Oh, yeah, you need a Aaron Vanucci rage right there. Thank you, Scuzzbot. Uncle Bill, did you bet against him? You probably should have. Let's go Doubters.
No, there's still 2 laps.
So on Twitch, there's believers and doubters. You are a 50-50 split right now.
Oh, I doubt. If someone tells me something, my go-to is to doubt it. I think it's the science.
A really common ingredient in food is MSG. Yes.
That's kind of a controversial topic because there are people who claim that they can detect it or that they're allergic to it. But I think the science, I don't know actually for sure. I haven't looked at this in depth, but I think the science is still out. Like there hasn't been any kind of conclusive study which says yay or nay to those claims. Well, now I'm in second.
Didn't bet, but trolling is fun anyway. Absolutely. That's half the reason Twitch exists, is to troll people.
Come on. Oh, Peach.
That's fine. You got star power.
Bumper, yeah.
Oh, worth it. Worth it. Take him down with you. But now you're like in 7th place.
Yeah, it's like a crab.
Yeah.
Why am I'm like, I don't...
Wow, the slope on that is brutal.
It's really...
If you get on that hill at all, you're just
done. It's worse if you've got, my fingers, and then, you just, can't control the thing. And maybe it's not the fingers that's the problem. Maybe it's the brain.
It's probably both.
An internal problem.
You haven't practiced enough. Obviously, you need to commit to speedrunning after tenure. I like it. All right, anyone just joining us? Ask a Scientist Gaming. We're here today to talk statistics with Jonathan Stewart. He's happy to answer any of your questions regarding network theory, exponential families, whatever it might be, Mario Kart, racing. Wow, you're back in second again. This game is just nonsense.
These kids can't drive. Well,
neither can you.
No. Well, darn.
So I don't remember on this version.
I'm
if you score less than 4th place, you have to do the race again. Is that the rule?
I don't know, but I can't make this jump apparently when it counts. These kids can't drive.
Great quote.
Although they're all they're computers. It's not.
Nope.
I'm just gonna brute force through it. No, I can't do it.
Oh, you just don't get points. You continue the race, but don't get
Okay.
points. These kids can't drive. It's mountain. Did you see that mountain in your way?
Well, you see, it's my thumb starts to hurt after a while, and so I'm kind of getting lazy with the joystick.
Yeah, that's
And
fair.
it's very sensitive on this game. Oh, I have to retry it.
Oh yeah, I think you have to. Yeah, I think you have to
Okay.
get higher than 4th, otherwise you don't. Which isn't bad because this doesn't hurt your point.
Well, but hold on, that changes the whole game. If I can't get lower than 6,
But you only get like to fail twice, and then you lose the race
okay.
entirely. So yeah, it's not repeated. I think you only get like 2 or 3 continues. At least that's how it was in Super Nintendo version. Somebody in chat can correct that if I'm wrong.
so it's a negative binomial. Kind of.
That's fair. But now you're practiced at this track. I think the answer is avoid the hill.
Avoid the hill. I think as long as I stay on the road, I won't lose.
This is generally good driving
Yeah.
advice.
Ghost. This one's kind of hard. And it doesn't look hard. It's not like, the Rainbow Mountain or whatever.
I think you just gotta
Rainbow
hit this
Road.
one straight.
There we go.
Nice.
Yeah.
All right, are you good on beer?
Oh, yes.
Okay. It's my excuse to drink during a weekday.
Oh, no. Well, better than falling. Let's see if I can some of these guys. That was a little bit of a waste of a banana. Unless people are going off-road. Ah, there he goes. Okay, I think this is the mountain of... Uh-oh, I'm starting to spin out. Okay, well, I hit the mountain, but at least I'm back on the road. Wii games. Yeah. So the Wii was a little bit after my gaming time, so I never really played it. I think GameCube was the last Nintendo system I owned. Uh-oh.
That's a fun factoid. Did you see that?
The driver carts
Sprites in Mario Kart 64 may look 3D, but they're actually really 2D. So they have no height. They're just an X. What would that
interesting.
be? That'd be like an XZ plane. That's fun. So it can only contact on surface. How does that work?
no.
Though?
How do I
that's
get
gonna
back?
cost it.
Oh my gosh, how do I get back? No, I can't do it. I can't. No. All right, we're gonna have to do a running start at this one.
I mean, that's interesting. So like if you're jumping, then if it's only truly a 2D hitbox, if you jump up in the air, you shouldn't hit somebody else, right? That's interesting. Are you familiar with hitboxes? Do you know where?
Yeah. Enough.
Yeah. Oh, you got that. It's mountain.
I am so bad at this. I don't know why this is deceptively hard.
Yeah.
Okay, now the question is going to be if I can actually catch up.
God, those hills are brutal.
They are. Maybe I'm not braking or, maybe I need to... Oh, 8th. Oh, that's worse than last time.
Yeah, I think you get one more try.
Oh my gosh.
And somebody can double check me on this, but
Oh,
one more try if you miss this.
wow. Okay.
I assume that means the sprites are pre-rendered into raster images. And hitboxes are an interesting thing, and especially speedrunning. Like, how close can you cut a corner without actually hitting something?
Yeah. I'm not really, something surgical doesn't seem to describe my approach to this. I would say it's more like a sledgehammer to a glass wall is how I would characterize my approach to this level.
Just this level.
The other levels maybe sledgehammer to drywall. But this one, no, glass wall.
That's amazing. All right, I better ask some questions. All right. So one question we ask is, what is the Earth is flat / anti-vax equivalent in your field? Like something that's just commonly misconstrued and at this point is maybe dogmatic in opposition to what you do or what people, conclusions they make with statistics. We talked about p-tests earlier. Is there anything that comes to mind? Oh, that particular turn is wrecking you.
Yeah, well, if you get caught on the thing, then on the slope, it doesn't seem to be able to. It doesn't seem like something you can correct.
Yeah, it's unforgiving.
Oops. And then there's just going off road. What is the Earth is flat? I don't know if. I mean,
so there's common people using averages versus medians. I mean, there's very.
But there are times you would want either.
Yeah.
I think actually, and this would be, what are they? I'm trying to remember the quote, but basically, statistics is all lies. People lie with statistics, and I think that this is probably at the same level of frustration that the Earth is flat is to certain types of scientists and other. I think if someone says the Earth is flat, that should be frustrating humanity. But I think probably that people think that people abuse statistics and lie, and that's true. But people do that with everything, There's lots of things where something can be good or bad. It depends on the user, and I think statistics as a discipline. Ooh, I made it that time. I think statistics as a discipline, for some people, they view it as fundamentally dishonest because they think, people use these statistics to lie or to on the news is fake news. It's all this type of almost propaganda to disbelieve, and I think there are people who and people have confronted me on this where they say, statistics, well, that's just fancy lying. It's like, what?
Ouch.
No, I actually had someone say that to me,
That's an airplane conversation, or?
Well, no, there was. I'd rather someone much older who thought they knew much more than they did, but at the time. But
that's fair. Your parents. That's fine.
Not my parents. Not my parents. No, they're much too smart for that. But someone asks what you do, and I say, I'm a statistician. They go, so you're like the lawyers, huh? You get paid to lie. No. So I think that's, because.
Yeah, so it's like
what is the quote? There's lies, damned lies, and statistics. I'm trying to remember the quote, but.
So that's an overarching problem you deal with as a statistician. Just disbelief.
Okay, finally, I'm second.
Second place. There we go. We're on to the next race.
So I think that's probably our Earth is flat. If not, then something with p-values. Journals. We don't use p-values anymore. You don't understand p-values, and they're not helpful for your field because some fields, a statistical approach doesn't help. There are certain types of social sciences which they don't actually get data and good data. And so statistics could actually not be the right toolkit for them. Sometimes a more, what's the word? holistic approach is better. I'm forgetting the word. There's a specific word for it. I don't do this type of analysis, so I guess I don't know what it is. I forgot the word, but
Yeah.
Qualitative analysis.
The thwomps.
Yeah, qualitative methodology can be very useful sometimes. I just got destroyed.
I know a ton of peeps that think past results change odds of future results. This lottery ball hasn't fallen in a while. That'll be my number this week. Yeah, the gambler's fallacy.
Yeah. So that's true and not true, right? So certain things, the past doesn't affect the future. But I mean, the stock price today absolutely affects the stock price tomorrow. But the change in stock prices might be, a different question,
Whoa. That was unexpected.
So yeah, I remember this level now. I'm gonna get destroyed. I don't know if I'm gonna be able to complete this circuit in time.
We're going to try.
But especially with gambling, and I think this is where most of that, what you're getting at, comes into play, is, and this shows up with stocks too, well, the stocks got to go up eventually, right? Everything has to average out. No, some companies go under. And with regards to like playing slot machines, if I keep playing, then this machine will eventually win. No, that's not true. And people make up stories all the time. Actually, I played a game in my class where people were strategizing, and one of the things that we mathematically proved was strategizing doesn't help. Strategizing
Still did it.
Strategizing doesn't do anything for you. And the game was simple. It was basically a rock, paper, scissors game. They hold up a colored piece of paper. There are 3. And the computer spits out a color. If it matches, you're out. If it, doesn't match, you survive. So if you play blue and the computer says blue, you're out. And people, were thinking like, oh, well, it didn't say this color, or it said this color twice in a row, it's probably not going to say it again. You can see people kind of deciding what to do, and in fact, nothing they do matters in terms of the odds.
Yeah. I mean, so strategizing matters if you have some inkling of like choices or like the game theory aspect of it. What will your opponent do? But if it's truly random number generation,
yeah,
which I guess is another question, is there true random number generation?
That's really a computer science question, I think.
Yeah.
I don't know the answer to that. We can certainly create random number generators, and we can run simulations for which we know the exact mathematical outcomes, and we can see that these mathematical outcomes replicated by the programs we write. If we expect to see something happen 1/3 of the time, if we run a simulation enough using a random number algorithm, then sure, 1/3 of the time it'll happen. I got 4th. Okay. So I don't know where I'm actually going to finish on this one. I don't think first or
No, there's still hope. Believers, stay. It's gonna work.
Okay, so I'm in.
There are some fun like random number generators that use like this.
Oh no, I'm in 2nd. Okay.
That's not.
Oh, but Wario has 30.
11 behind. You might be able to make that up. But there are some random number generators that use like crazy random influences, like the static noise of the black body radiation of the universe to come up with numbers, right? So like truly influenced randomness. Was this the end?
Maybe so. Maybe I'm 2nd. Well, but the thing is there are certain things that the world organizes. Entropy is not the state of everything, and probability is an example of this. Statistics is an example of this. Look at birthdays. it's not total entropy. The total entropy state is every birthday is equally likely,
Yeah,
right?
1 out of 365.
But the second
yep.
you start to concentrate probability mass on certain birthdays being more likely, the total absence of entropy is sureness, right? Constants. This is the outcome 100% of the time. So, when you use things in the world, they might not behave perfectly random or uniformly random. That's a big challenge. And I think one of the big challenges in constructing random number generators. I don't know enough about it, but
So
there are things in the world that you expect not, things should be uniform, and they're not. And how does that bias influence something? If you used it as kind of, a sampling distribution for random numbers. I don't know.
So, will Jonathan take first this round? The answer is no. Skeptics, congratulations on your factoid request
I
and your
did not.
drinks.
All
right. So,
I got second.
we got about 20 minutes left. I think it is time for the final game of the evening, the classic Ask a Scientist Gaming. We close with the game NARC. Are you ready for this?
Oh, okay.
This is a clear demonstration we've lost the war on drugs.
Okay.
So, Nintendo controller.
Oh, this one now.
Yep.
Okay.
Press the start button. B, if you tap it, jumps. B, if you hold it, squats. A, if you tap it, rockets. A, if you hold it, shoots. Deku, darling, you are correct to celebrate. Oh man, I didn't even put the speedrun split on there.
Okay, so I need to...
There we go. We'll start it. So basically, it's walk right and find doors is your goal in this game.
Okay.
Killing people doesn't give you anything.
Oh, okay. What if I just want to watch the world burn?
Then, by all means,
Who are
blow
these
up.
people?
These are flashers. Just kidding. They're drug dealers in a junkyard, apparently.
Just wearing
Trench coats.
trench coats.
Realistic depiction of the war on drugs. All right, Uncle Bill. There's a company with a wall of lava lamps and cameras watching them to generate seeds for random number generators. That is pretty amazing.
So I what I would say to that is, it's very easy to test, how random things are, right? Can you find correlations and other things? I don't do this, but there are ways to do this to, essentially look for trends and to see, like, are things actually random?
So that's interesting. How do you test for randomness?
Oh, thanks. Yeah, I just walk. So you see, again, I don't know enough about this, but I know that people have explored these things and have come up with tests that have proven that certain, algorithms for generating random numbers are better than others. And I'd have to read a lot more about it, because I just...
I mean, so in a broad sweeping sense, they try to fit a data set to something like a polynomial and see if it makes sense. I mean, truly random, you can't fit anything, right?
So I'm not sure how, because just because the randomness behaves correctly, that is, you run a simulation with a known result and you get that result, doesn't mean that it's actually random. Because what does it mean for something to be totally random? I mean, think of your classical statistics, IID, independent, identically distributed. I need the safe. Okay.
Yep, you need the card, and then you'll go right and use the card eventually.
Okay.
Then I'll let you go right. Deku Darling has redeemed. Take a drink. So, Jonathan, cheers. And thank you for playing NARC. I ask my guests every time, what games do you want to play? Also, you're playing NARC. Yeah. And they usually say yes.
That's interesting.
So basically, the third time we did a stream, I was the guest, and I had one of my colleagues in chemistry, the host, Eugene DePrince, and I played this game, and somehow I don't know, it became a trend, because this was one of the early, look, you're blowing up people, and there's body parts, and there's blood. This is one of the ones that created the game rating system.
Well, it's important. Oh, I have to go there.
And then go through the door, yep.
Yeah.
But now this is one of my favorite games, so I got that
It's
going
interesting. Sure.
That is a polite way to say it.
Oh, now they've changed their costumes. Oh, so there's a mix of the people now.
So I'll throw in a science question as we approach the end of the night. What's something you're really excited about right now? Research-wise.
Yeah. Oh, my research or just in my field?
Well, could be either. Well, let's take either answer. Let's start with your research and then let's go broader to the field.
So with my research, something that I'm really excited about is converging two lines of research. So there have been kind of two approaches to modeling networks statistically. And I kind of classify these as macroscopic versus microscopic looks at the network. You know, when you look at a network from like an aerial view, you can see like clustering, like, you know, certain, you know, people might group together. There might be some kind of a spatial representation to the network. And there's many classes of latent models that try and...
I'm sorry to interrupt.
Oh,
so
sorry.
to get the key here, you have to shoot them and not rocket them.
Oh, how do I shoot?
So hold A.
Hold
and the
A.
bullets will
Oh.
just come out. So if you squat, you can shoot the dog.
I see.
So hold B and A, and there you go.
Okay.
And the blue card will drop eventually.
Okay. I've got the blue one.
So that's not the card yet.
Oh,
but
that's
yeah,
not.
yeah. Sorry. Anyway, the thing you're
okay.
excited about in your field. There you go.
Oh,
Nice.
see. Okay, so now I go here.
Yep.
Oh, but here and
Yep.
then okay.
There you go.
Is to actually, you know, combine these two lines of research. My research focuses on dependent data and dependent interactions in networks and finding, you know, understanding how we can model these, when we can get good, desirable statistical results for the models we want, and the reason why these types of things are interesting is because if you think about who you're friends with in a network, right, or who you collaborate with, if you and someone else have a common friend or a common collaborator, it turns out that you're often much, much, much more likely to be friends or collaborate. And this is network called network transitivity. It forms triads in networks. You know, you're friends with James. James is friends with Lynn. So you're more likely to be friends with Lynn. Is basically how this goes. And this is observed empirically in so many. Oh, I get
So
a
you
car.
can jump in the car.
How do I hit A or B?
B. Yep.
Okay.
There you go.
I'm gonna run
Here's
these
the
guys
tragedy of the car.
over. I'm gonna run people over. Oh, I didn't get to run anyone over.
You have to memorize the pattern that you don't know because you've never played this game
okay.
before. Yeah, no, it's not fun gameplay, and I apologize that happened to you. But you got the car momentarily.
Yeah.
But anyway, transitive properties in terms of networks.
So in terms of modeling these types of I mean, this is you know, decades long that people have considered these challenging questions. And in the statistics literature and the social network literature and the statistical network analysis literature. And we've made a lot of progress in the last decade on these, I think, on these problems. So what I'm really excited to do is now to look at combining these two approaches, because neither approach is, I think, getting it 100% correct. And it would take me too long to go over why. How do I can jump.
There you go.
Okay. But what I'm really excited about is some new ideas that I have to kind of take the best of both worlds. And we've already explored this to some degree and have published something on this. But I'm really excited to kind of see how far we can take these ideas, because I think what we would present is a more general set of models and for an analyzing network data, and allow people, and the models hopefully will better represent reality, because we're combining hopefully the best of two classes of models that are very popular and have been researched a lot.
So is this a 2-year project, 10-year project, lifetime project?
I don't know. It's definitely more than 2 years.
Hopefully
5 sounds about right.
5. Pre-10-year project would be
yeah.
nice.
Yeah.
Yeah.
But it's one line of research that I think is really cool. You know, we tend to work on a lot of stuff at one time. So I'm hoping to, I have friends who don't do network analysis, but they do probabilistic modeling of cancer dynamics, and so I'm interested to do something with them because it's fun to work with your friends and write papers. But I think for me this is what I'm most excited about. Oh, I get another car.
So stay on the bottom at least initially. Oh.
Do I need the
Somebody
car?
clip that. It's a classic. I mean, it's just slower if you have to walk. So just walk right.
Okay.
This is the terrible part about this level. This is the slowest level in the game.
I see.
If the card doesn't work, you're on foot, just walking along. This is enthralling gameplay, by the way.
Yeah.
All right, so that's your personal holy
Yeah,
grail. What about in the
I
community?
think.
What are you excited about?
In the community, I'm really excited about. In my field, is kind of more research being directed at kind of modeling network dependence. So I'm seeing more people kind of researching this problem, and maybe it's I think certain types of models can only go so far. You have to have developments. We're not even close to the so-called holy grail of for in our field, my field. We're not even close, and I don't know that there is one because I think it depends so much on the discipline. Certain models work really well in some disciplines, and certain models don't work well in other disciplines. And so for my field, at least, I'm really excited by some of the research that I've seen where people are focusing more on what I consider the dependent network data setting, where we find people looking at modeling and studying behavior of kind of dependent properties of networks. I don't want to get too into the weeds with it, but I'm really excited to see a lot of new theory and methods for this. And
so there is like a unified model theory or something. Like physics has a grand unified theory where they want to combine quantum mechanics with big physics. So that exists in statistics as well. There's a
unified theory.
Nope, that was perfect.
Okay.
You didn't have a choice there.
Now, how do I get through? Oh, there we go. A unified theory. I don't know. I mean, and
unified model.
Yeah. So here's why. What I was thinking about that is because it's generally my opinion that there's not a holy grail model. Like the holy grail model is you have an infinite amount of data and you can fit any model, so you can choose the best model out of all possible models. But I think the other one of the big things is that every network is different. A collaboration network is different than a friendship network, is different than a contact network for a disease, is different than a protein regulation network. And so I think we will never get to that. I think the world would be very boring if we did. One model to rule them all. No.
No, that's fair. Just want to point out you're being stabbed by clowns.
I
because that's
why do clowns like drugs?
I pretty much have to at this point.
I guess so. I saw the new It movies recently.
Yeah,
they're good.
And you saw the old It movies.
Oh yes,
yeah.
I love horror movies.
Like, terrifying.
Oh, I love them.
They're kind of campy now, but I still like them.
Yeah, I do think they did a good job with the new one. Oh, right. I keep forgetting that this is not a game in which you have to, that these people will come.
It does nothing if you kill people.
Yeah.
So you have to get that white card that's at the end.
Oh, I need to go get this. Okay.
I don't think there will ever be a unified theory in mathematics or related areas. Pick your model's axiom-based assumptions and work from there.
Okay, so now I go this way.
That's a question. Like, if you have this like really good network theory model, shouldn't it be able to describe everything from disease transmission to, social friendship networks on Facebook? Is there a overarching model that describes them all?
I think what I would talk about is regression. Like, why do we use why do we do model selection and regression? Because oh, there it is. Thank you.
No worries.
So
this is the only one you go left on.
Okay.
Those are pot plants, obviously.
Yeah, I guess so.
Selecting.
Is that what it is?
Yeah, no, this is a grow house for marijuana.
Okay.
And some of them are laced with explosives.
Why? So why do I think there's not? Because I think the number of possibilities is not finite. How do I get out of here? I didn't.
Card, yeah.
Oh, I have to.
The ramble.
Okay, I see. No, that's not it. Okay. Oh, there we go. Okay. The reason is I think the the number of possibilities is just too numerous, and so if you wanted a framework or a class of models that could model everything, your class would need to be in some ways infinitely flexible, right? And that's a tall order.
That's not tractable.
Yeah, and I could talk more about it. I mean, that's kind of what the field of non-parametric statistics wants to do, right? Where you don't specify a parametric form for your model, you try and learn it, but I mean, you still have to apply some constraints. You can't you can't just estimate anything. You can't estimate. You need enough information in the system, right? If you only have n data points, you can't learn n+1 coefficients, right? So to speak. It's like how many models will, how many lines pass through 2 points? Well, 1. How many quadratics pass through 2 points? An infinite number.
Yeah.
And this is related to degrees of freedom, if and learn, and yeah, but. So, any model that would, any class of models that would be, theoretically perfect, or the Holy Grail, would somehow need to account for all of the infinite variations that you could possibly have. And how do you even, go about, so that's why I say, some models work really well in certain types of fields or certain type of applications, and others do better in others. And that's why there's value in I think researching lots of different models and lots of different classes. I'm not a very territorial person. Some people, are very aggressive against things that they research, but I think, I don't take that viewpoint, because they are funded, they are doing research, and their research has value, and is equally as valid as mine or someone else's research.
So this might be a naive perspective, but it sounds like you're touching on like Gödel's incompleteness theorem, where it's like you can't have an internally consistent, like there's fundamental limits on how much you can prove something can be universal.
Yeah.
Right? There's just limit, like fundamental, that the universe will not allow.
I think so.
Kaio
all models
Sagani, 1996, scientists playing games on Twitch. What kind of data do you study? Welcome to the chat. Thank you for swinging by. It's Ask a Scientist Gaming, mediocre gameplay expert at Level Science. My guest today is Jonathan Stewart, who's a statistician. So the question is, what kind of data do you study?
So I study, so the type of, the field of statistics I research is called statistical network analysis. And so the data that I'm interested in the models, so I would say, I would call it network data. And what is network data? The data is the network. So you can imagine a set of people, perhaps they're network scientists or students, and there are relations between them, whether they write a paper together, whether they're friends, whether they go out to dinner, and
whether they transmit STDs. All of it, network information.
So so we view these connections or relations as random. And what we're interested in doing is learning the nature of that randomness, understanding how networks organize. Oh, do I have the card?
Yep,
yes.
You have the red, blue, and whatever cards.
Oh, great. And so that's the type of data, as it were. So, you can represent this as an adjacency matrix or an edge list. There's lots of ways you can represent the network in terms of data structures that could communicate or store the network information. But fundamentally, I call it network data.
KO, welcome to the stream. Yes, NARC is a favorite of Ask a Scientist Gaming. Every other Wednesday we have a guest on, and I make them play NARC because it is a classic. It's a bargain bin. Like, you remember going to Blockbuster and seeing games, and they always had like the $2 discount games. This is that game, which you are gonna beat tonight because you have infinite lives, infinite arrows, infinite rockets.
Yeah.
So you're about, I don't know, this is almost the end of the level.
Oh, wow.
A guy in a wheelchair will show up and you have to rocket him. So heads up.
Oh,
There
do I
he
have a
is.
rocket?
Yep,
Oh,
you have plenty of rockets. So tap A to rocket.
okay.
Yep, there you go. So you'll need to rocket him 3 times. So yes, this is a game that, started the rating system basically. It made it
Wow.
or was one of the ones that contributed to why
This guy's pretty quick.
Yeah, in a wheelchair. He's got moves.
Yeah.
And he's shooting at you. So I'm kind of impressed. Like, you feel bad a little bit shooting a guy in a wheelchair, but then inchworms away. All right, last minute questions. Jonathan is about to beat NARC, so if you have any questions for a statistician that's an expert in network theory, ask those questions now, because he's going to answer them while playing NARC and killing a guy in a wheelchair.
I feel bad for him.
I mean, you'll see what he turns into in the next level, so you shouldn't feel that bad.
Uh-oh.
I think he might be better than the boss.
Is that him?
Fox.
Is that him over there?
Yeah, that is him in the
Oh,
portrait.
okay.
This might be a better bad guy than Star Fox. I'm not sure.
All right. If I could finally hit this guy, he's kind of slippery.
Yeah. Yeah, this is...
Okay, there we go.
There you go. All right, now he turns into a card somehow. All right, there you go. Gold card, you are onto the last boss of NARC. This is it.
All right.
Now, this boss, you have to jump and shoot him in the hat/glasses, and then shoot him in the face 3 or 4 times.
Jump and shoot him in the hat. Class.
Yeah. Now, Kaio has the history here. Mortal Kombat and Lethal Enforcers, they triggered the panic, and they had like a Senate session to discuss video games and whether they were too violent and causing violence amongst children. Yeah, that's what created... Oh, there you go. You got him. So now you just shoot rockets straight at his face, and you'll expose the skull. That is amazing. You might have the record for the fastest guess getting him to the...
Well, you did tell me what to do.
I've told everyone what to do. It's a difference between executing...
Well, I have to make up for my wonderful Mario Kart mountain hitting skills.
So one thing you can do to avoid he's shooting lasers out of his eyes is go to the top of the screen.
So I can outrun him.
Oh, just go to the top of the screen. I don't think he can hit you at all.
Oh, okay. Oh, interesting.
There you go. Okay, so now with the bullets at his spinal cord.
Oh.
There it is, the 1993 congressional hearing on video games. So you have a bunch of 65-year-olds in 1993 talking about modern video gaming. It is a sight to see. Yes. Well, even in the NES version, this snuck by. Like, NES has a like squeaky clean image, right?
Mm-hmm.
They like Mario and Luigi, but this game was produced by NES, so it was released. But they changed words like crack to quack, and they toned down the blood, but there's still blood in this game when the clowns stab you. So this is stupid. Basically, run right, move up or down on the screen, and then shoot left. And I don't know how this works or how the hitboxes are controlled. It's absolutely insane. But my fun factoid for you is I'm the record holder in the speed run of this game. So that started as a joke where people like, we played this every Ask a Scientist, and they're like, the record's
Am I
only
doing
9
this
minutes
right?
and 28 seconds. You can beat it. So go back. It's really, I think you got one of the vertebrae. Yeah, you're doing it right by shooting the spine. So now bring him back to the left and then drag him to the right.
Do I fire at him like now, right now? Or does
So
it...
you can't shoot from... So for some reason, you can't shoot left to right on him. You have to shoot right to left, but you have to drag him that way before you can go back the other way. So the rockets don't do anything on the vertebrae. You have to do... talking to Caillou right now. So yeah, so go right.
And then I shoot like that?
Yep.
really tedious.
No, it's really frustrating. And what's crazy is like you'd think you'd pick a perfect position on the screen and you should be able to hit it.
Yeah.
But it depends how you position when he's moving his head around.
Oh, I see.
So this is like random number generator for some crazy reason.
Or just like me dying. 'Cause I can't get around him.
That's frustrating. If you get overly frustrated, let me know. I can show you how this fight unfolds, because it's absolutely insane.
Die.
Do you regret agreeing to this game? Because you beat Star Fox tonight. I mean,
Yeah.
that's got to count for something.
Yeah. I don't understand how to hit him.
So he's down to 4 vertebrae, so you've killed already.
Oh, I have.
3 of,
Okay.
3 of the 7.
Okay.
So it really is a matter of getting to the right and finding the sweet spot. So you drag him back to the left and go back the other way.
Huh.
He doesn't shoot
Wow.
anything, but he's not
Yeah.
a super threatening.
Yeah, but he's very good at running you over.
Yeah,
I mean,
under his arm.
I haven't found out yet how to get around him. Okay.
So I like to use this, like my speedrunning strategy
Yeah.
in this game is a perfect example of scientific method.
Yeah.
Because what I literally just did is try different things to see what rules govern his behavior, and then manipulate those rules to do exactly what I want. And that's
So am I doing? How am I doing?
bring him back left, go right.
Yeah. I think I need to walk him further.
Yeah. And what I generally do is I move this way, move to a position, and then shoot back that way.
Oh, I see.
Hope that your timing and your positioning is right to actually kill the vertebrae.
I see.
Believe it or not, you are doing better than 99% of the guests that play this game, because it is.
This is a very frustrating one.
Yeah, no, the hitboxes are. So now I would move up and just turn around and shoot. There, you got another one. So the last 3 vertebrae are the easiest. So I'd go down. But do we know if that's true 99%? Jonathan, I want you to work with me to figure out this game. Do a rigorous statistical analysis on board positioning and vertebrae shot. I'm sure we can invoke some network theory in here somewhere. Maybe some exponential families. No, it's really fun. Is my brother? He's a computer and electrical engineer, and he's actually reverse engineering this game to figure this out. And he's doing it as fun and as well as like both of us together. We're going to figure out how to do this. You know, it's our recreational hobby.
Yeah. I wish I knew how to do that. Unfortunately, I don't know how to do such things.
Yeah.
Okay.
Oh, there's another one. You're down to 2. You got this.
All right.
Go right.
Oh, I have to go more right.
Yeah.
Okay.
Because the best level of the game is coming.
Oh, we're not done.
Nope. There's one more level.
Okay. Could I have just gone out of here and skipped him?
No, you got to get him to get the card.
Okay.
All right, this is civil forfeiture of the level. So this is where you collect money with no due process whatsoever. You're just stealing money from drug dealers. So enjoy your collection of gold bars.
Well, better me than them. I used a lot of bullets on this.
No, that's true. You earned this victory.
Rockets,
Congratulations.
helmets. This stuff is very expensive.
And that is officially, that's time. 27 minutes and 14 seconds on
All right. How did I do? What's your fastest time?
9 minutes and 24
That's
seconds.
fast. That's fast.
Yeah, believe it or not, this game you can basically walk right and not stop the entire time. So I'll send you a clip of the speed run in case you're interested.
Yeah,
in
send it to
deeper,
me.
But
Hey, it's only 9 minutes. I got 9
yeah,
minutes.
no, exactly.
Congratulations. my initials.
Yep. So you can put your initials in there, or if you put ass in there, it doubles your score. Entirely up
really?
to you. Yes.
That's very interesting.
No, put your initials. You earned it.
How do I go back?
All right.
Rub this. Oh, there we go.
Yeah, that's a race. If anyone has suggestions on people we should raid, please throw them in chat right now, because we should raid somebody. Preferably science and technology, but doesn't necessarily have to be. But either way, again, thank you for swinging by Ask a Scientist Gaming, mediocre gameplay with expert level science. Jonathan Stewart beat both Star Fox 64 as well as NARC, and had a pretty good run at Mario Kart. second place in 3 different rounds, 3 different levels. So yeah, Jonathan, if you have any parting words for the audience, go ahead and throw them out now.
Disu, we got a Disu, darling.
Disu, darling. Disu.
Interesting.
Thank you. That has been bothering me the entire time. Phonetics, it works. All right. Jonathan, any parting words for the audience?
You know, I guess I would say, you know, just study statistics. It can take you places.
That's the pitch. It's time.
We have quite a number of degrees at Florida State, so come on down.
We should figure out some way to collaborate on something.
Yeah, that'd be fun.
Yeah, apply it to a unique model. That's the thing about most of our chemistry and physics is we take, 50-year-old math and statistics problems and then apply them and pretend they're new. So,
it's interesting. I think some statisticians at SMU in Dallas wrote a paper on wine. So you could find interest everywhere.
That is amazing. All right, everyone. Thank you for stopping by. Again, this is Ask a Scientist Gaming, mediocre gameplay, expert level science. My guest today was Jonathan Stewart, statistician, talking about network theory, also playing Star Fox, as well as Mario Kart, as well as NARC. That's awesome. Thank you again for swinging by. This is an unusual request. I actually sent this a blind request through Reddit, and Jonathan was kind enough to accept. In 2 weeks, we'll have Christina Holmes, who's a chemical engineer / biomedical engineer who works at bioelectronic interfaces and things like that. So yeah, swing by, see us again in 2 weeks. It's always a pleasure to have you guys in chat. Your questions are really what drives this channel forward. So yeah, until then, it's been a pleasure, and we look forward to seeing you guys again. Stick around, and we're gonna raid. Looks like Diatom's Attacks is on, so stick around and we'll raid him. So we'll see you guys later.